Good morning everyone, and a warm welcome to the OW2online conference. Thank you for attending this special edition. I sincerely hope you all well and safe. As many of us, I suppose, I would have liked shaking hands, sharing a coffee, chit-chatting between talks. But don't worry, despite of this condition, we have cooked an exciting program for this special edition of OW2Con, thanks to all the speakers and our wonderful staff. The choice of going online was a difficult one, not only because we had to face in a really short time some new technical challenges, but because it was about finding a fair balance. This balance many of us was forced to find ourselves during this crisis. This balance between freedom of meeting each other, the security of our health, of your health, and the responsibility we can endorse or we want to delegate. There is no obvious answer. I like to quote these words from Isabelle Autissier, a famous yachtswoman. Freedom, security, and responsibility are the three vertices of an impossible triangle. In our everyday life, personal or professional, I believe we are facing this choice. Hopefully, with less critical stakes most of the time. As a free software advocate, as a member of OW2 community, I yet believe this is our mission to help software users finding this balance. Of course, every user wants to be free for software vendor lock-in and is concerned about privacy. The recent example of Zoom privacy concerns demonstrated this concern go far beyond the geeks community. But as an IT department manager, can I take the responsibility of deploying a free software-based solution for my users that depend on it for their everyday work? What security can I give to them? Is the community-driven software safe? Who should I speak to in case of failure, of bug? The free software gives me the possibility to edit the software on my own and fix it. That's fine. But can I take this responsibility? For 13 years now, it has been OW2's mission to build a trustful, secure, sustainable free software ecosystem that never compromises on freedom. We host free software projects, not open core projects, not badgers. Free software. There is no discussion about this. We have developed strong quality assessment tools for these projects. As a free software user and developer for 20 years now, I am convinced free software development model intrinsically brings a better quality. But this is not enough. We need to demonstrate it. So do we. With projects like Riskcourse, CrossMiner, we are now able to provide users comprehensive quality metrics. With projects like Stamp, we are providing developer tools to improve the quality of their code in a really innovative way. And now, on top of these tools, we are able to build a business case that gives at a glance the maturity level of a project. This is the market readiness level. Finally, the OW2 industry members are not only developing free software, they are also able to take the responsibility of the integration, the maintenance, and the support of comprehensive IT solutions. Thanks to ongoing efforts from OW2 community and others, thinking of Open Source Initiative, Free Software Foundation, Eclipse Foundation, and so many others, free software is now recognized as a credible, sustainable, and secure investment. In particular, we want to greet the recent adoption by the European Parliament of a resolution that prioritizes investment in free software. This definitely acknowledges the free software ecosystem in general as a solid industry. That complete the ongoing support from a European Commission to free software development through research projects for many years now. In this context, we also want to welcome the Eclipse Foundation that recently moved its headquarters to Europe this year. With collaboration in mind, we are looking forward to strengthen the position of free software in Europe. That being said, let's hit the road for this OW2 online conference. I will let Cédric Thomas present in details these 2 days of wonderful keynotes and project presentations. Thank you and welcome again to OW2 Online.
Welcome to OW2Con 20. Well, first of all, I hope you're all healthy and well and safe. And precisely because of the pandemic, this conference is a bit special. With the pandemic going on and travel bans and lockdown, we had to make the decision to take OW2 online. So we waited until the last minute, but eventually we decided to turn OW2Con into a virtual event. But we also decided to keep the dates. So this virtual conference is on June 17th and 18th. And we've also decided to organize a face-to-face event. As a community, we need informal conversations. We need to meet. So we have decided to still organize, after lockdown, when all this is over, in November the 3rd, we hope, a face-to-face event, which we call OW2 Community Day. So this year's conference is twofold. The online event is OW2 Online. It's a series of presentations. We kept our usual 15-minute format, and we've decided to play it safe with a combination of recorded presentations and live chat, live interactivity with the speakers. And November, there will be the face-to-face event, so it will be more festive. The OW2 Community Day will have a program of keynote addresses, roundtables, the OW2 Best Project Awards, the famous OW2 Free Beer Party, and we've set aside plenty of time for informal conversations. So this is what we have this year, OW2 Online and OW2 Community Day. OW2 Online runs on open source software. It was a requirement for us, of course, and we're very proud of the platform we've put together. In barely 1 month, we've totally re-engineered our technical environment, and this is open source software at its best. We've used some of our projects. We've benefited from the support and responsiveness of our speakers. So this is, again, true open source software and community collaboration in action. The platform we've put together runs on OW2 projects Rocket Chat and XWiki. We've used pre-talks for the program. We've used OBS for the video operations. And for the streaming, we've decided to play it safe and go through YouTube Live. All this has been possible thanks to the efforts of many people. So it's time for some thank yous, of course. First of all, the OW2 Management Office. Fortunately, we are all home-based, and the lockdown has not been too disruptive for us. And we've managed to spend our lockdown time busy working on re-engineering OW2Con and preparing this new platform. We've also benefited from the support and understanding of our speakers, to whom we have communicated a new process. So they all really adapted well. It hasn't been very easy for all of them. It's a difficult exercise, and even some of them did not make it. So congratulations to all the speakers on the program. And of course, our sponsors. Their support and trust mean a lot to us. So thank you, Orange, Software Heritage, Engineering, Funding Box, the Eclipse Foundation, BlueMind, and Microsoft. And speakers representing 13 nationalities. And this is packed in 5 sessions. So the first session is about ecosystem. So it's looking at open source not so much as a way to collaboratively develop software and have open source licenses to software, but really open source as part of our economies. The second session is concentrates on the OW2 code base with some highlights on some of our projects. The third session is concentrates on, we call it open source state of the art. And it looks at open source as a way to design and implement more efficient and desirable solutions. The fourth session is concentrates on collaborative research projects that are enabled by open source software. And the last session, the fifth session, which will take place on the second day, is about governance, but not so much about compliance, but the tools about compliance. It's a big coverage of all the resources about compliance and managing open source software within an organization. But it's also about what we call implementing good open source governance. Now, I still have some housekeeping instructions or indications left. So first of all, as I said, the presentations are recorded and are all programmed to start on time. So the timing is indicated in the program, so refer to the program to organize your day. With this session, we will launch a chat channel with the speaker behind, so you can directly interact with the speaker. And of course, the chat channels will remain open throughout the rest of the conference. We will have coffee breaks, lunch breaks, and of course the chat channels will be open throughout the breaks. You notice on the side there are 2 official channels. One is for help, where you can ask questions if you have any difficulty or any question to ask us. And the other channel is for general announcements. So keep an eye on these channels. The OW2 management office is behind, and each of us has a role to play, and will be monitoring this the whole conference, the whole online conference. So with that, I'm excited to open OW2 Online. It's something we've never done before. We're still learning. It's a trial. So we hope you will understand if things are not as smooth or seamless as you would expect them to be. But we've done our best. And we hope you're going to enjoy the experience as much as we've enjoyed working on it. So without further ado, I'm happy to declare OW2 Online open and wish you a great conference. And our next speaker is Luis Busquets from the European Commission. Luis works at the DG Connect, and as such, he's one of the people helping shape the Commission's vision of our own ecosystem.
Good morning, ladies and gentlemen. For me, it would have been an enormous pleasure to physically meet you. Unfortunately, for reasons beyond our power, this has not been possible. Anyway, it is also an immense pleasure to virtually meet you, and I would like to thank you for your interest in open source and also for your contributions to open source, because each contribution made to an open source project is a present to the whole humankind. We must be proud of working in the ICT sector. It is this technological domain, the one which has managed to make all humans share a single global village. And it is showing its power during the global pandemics. The ICT technology has put the biggest library one can imagine in the hand of each human, and it is also responsible of the next industrial revolution to come. And what about open source? How is it contributing to our domain? Several decades ago, when I was a kid and I discovered computers and programming with my first Commodore 64, I wondered how that device could actually perform so many operations and respond to the commands that I was writing. And I could not imagine how complex was that. In my imagination, the computer should not be much complex than the mechanism that made the doll of my sister cry, just a battery, an engine, and a disc with a melody. All those who love engineering and are of a similar age as I know what I'm talking about. But, well, the mechanism to make the doll seem like crying was a fairly simple mechanism. However, to understand how a microcomputer worked did not only require opening up the box, but also to have information on what the different parts did. Certainly at that time, I was also missing the engineering knowledge to understand how it worked, but that excuse did not last for long. When I reached the university and already counted with enough engineering knowledge, I could only realize that the understanding of the engineering principles was not enough. There was a bunch amount of information that was required in order to repair my faulty computer. The advent of the latest operating systems at that time made it seem that an increasing number of black boxes would be in our lives. And not only that, the black boxes seemed to expand in size as time went by. A sufficiently advanced technology is indistinguishable of magic, and such expanding black boxes seem to drive to a world where we should consider technology as magics. Thank God, something changed. The history of open source is much longer, but my first contact with open source was only 2 decades ago. The possibility to explore the code buried any idea of just relying on the magical power of a computer to work. I felt I had the same control of the device as I had when I programmed my C64 in assembler. Full control, full understanding, well, at least at the code level. These 2 last decades have seen how open source spread from the house of geeks to everywhere else. 15 years ago, there were big ideological fights on open source, yes or no. Between black and white, the answer is always a sort of gray. Those times have passed. The market is well aware of the value, and investors understand the huge value and potential of open source. The latest years have seen multi-billion operations for purchasing companies working with open source business models. These capital investments are the tip of the iceberg, but the iceberg is much bigger. When I tell my non-IT friends that a smartphone is full of open source, they ask me, but what is open source? Anyway, for innovators, open source is proving crucial. And because of that, DG Connect is carrying out a study on the economic impact of open source software and hardware in the European economy. This study is identifying strengths, weaknesses, opportunities, and challenges of open source in relevant ICT policies, cybersecurity, artificial intelligence, digitizing the European industry, the connected car, high-performance computing, big data, distributed ledger technologies, all fields in ICT used to a certain degree open source, and no longer just ICT, but also industrial sectors seem in the verge of the open source evolution. Software is driving the incoming technological revolution and facilitates the adoption of the latest state-of-the-art in cutting-edge technologies, such as the Internet of Things and artificial intelligence. The hardware implementation dictates the limit of the capacity of a device. 30 years ago, hardware limits were also the limits of the functionality of the device. However, this is no longer true. The functionalities of the device come now from the software that is inside, and the continuous updates of the devices adds customers with new possibilities that did not have at the moment of the purchase of the device, even if the hardware had got that possibility, but you needed to have implemented in software. Open source allows the user to add these missing functionalities on hardware that is capable of much more. Open source. So far we're just speaking about open source software, and for decades it has been like that. However, nowadays open source is far more than open source software. For that, the study aims to identify the impact of open source software and hardware. Open source software is the elder brother, but now we also speak about open source hardware and open science in the scientific domain. The ideas of open source software in the IT have transferred and spread it to other scientific places. Open source hardware is an enormous field with very different technologies. We speak about 3D printing, but also about open computing, open electronics, open silicon. The Red Wrap 3D printer constitutes an ecosystem on its own in its global dimension. OSH shares with OSS its modularity and self-assembly feature. If OSH is to follow the same development as OSS, the demand for OSH would develop rapidly in the next decade. It could constitute a cornerstone of the Internet of Things, the future computing, and the European industry at the end of the next decade, in a very similar way as how the Linux kernel and open source are powering hundreds of millions of smartphones today. The number of open source hardware projects seems to be following the exponential growth of open source software. Watching at the world map and discovering so many locations for Fab Labs makes imagination fly, and how easy to build things is. Why is it important? Is it that any of us expect our mother-in-law will go to a Fab Lab to fabricate the device she needs? Of course not. Who is going to use open source assets? Well, these are the innovators, the entrepreneurs, who do not need to start from scratch, but to concentrate on the value added of their innovation, because the rest, they can use it, modify it, distribute it, and also contribute back to the community. Open source is the level playing field for all, big companies, small companies, startups, spin-offs. Any person in the world can benefit from open source. And let me share you a slide that was presented at the workshop on Open Source Beyond 2020 held in DigiConnect premises last November. This slide is not mine, but the presenter kindly agreed to allow me to use it. It comes from a global collaboration facility to develop open computer architectures. The idea behind it certainly captures the attention of any open source aware engineer. During decades, the open source communities have built a full software stack from the operating system level to the application level. Actually, to many different applications, and because of the nature of open source, on many different hardware architectures. This specific open source project is concentrating on providing an equivalent open platform below the level of the operating system. The central theme of OW2 conference this year is the challenges of a full stack open source. Open source software across the whole information system. That is more than deploying open source in the servers, but in the whole architecture. The whole architecture at the IT level. That would be at the application level of this graphic, or even over the whole column. I would like to start challenging you and not only think about afterwards, but what about the hardware level? Open source is here and is here to stay, and open source hardware is knocking at the door. The level of maturity of open source hardware remains far lower. However, the business ecosystem of open source hardware is developing fast. To what extent the full stack open source should also cover up to the sun in the beach? Imagine you were magically transferred to the 18th century. What information would you need to carry in order to build a computer from scratch? From the sun in the beach? Well, that is fantasy. But what is not fantasy is that lately there are some frontiers that have been raised for certain technologies in the ICT world. Open source has proven to be immune to those frontiers, and by that constitutes a powerful tool of digital sovereignty. Open source is meant to have a big say in the future of ICT and the Internet, building a next-generation human Internet that respects the human fundamental values of privacy, participation, and diversity is not an easy job. Open source is a fantastic tool to deploy our common EU shared values in the next-generation Internet and offer new functionalities to support people's needs and to address global sustainability challenges. Open source may be an alternative to proprietary solutions. However, it does not need to replace successful business models to have an effect. To a certain extent, the ideas of 15 years ago of open source replacing any other business model in IT have proven not correct. However, open source has been extremely successful everywhere, including where there were no competitive stakeholders. Its mere existence has increased competitive pressure towards innovation in IT markets, lowering barriers for new entrants, reducing the burden to use what had already been developed, and converting real innovation in the only key to success. And what about those who were already at the top. Well, open source has also helped them to stay awake and to compete and to continue developing, not to get asleep, to increase the possibilities and functionalities of their products, and all that for the benefit of the citizens and the whole humankind, which comes now with much better products with what it would have without the competition that has been introduced by open source. Europe is strong in software. It counts with market leaders in industrial software and giants in the video game industry. The software and software-based services market is acting in every sector and provides the EU economy with the current state-of-the-art IT tools it needs to stay competitive. But let's keep awake. It is not for granted that Europe will keep on at the top, but by working hard, by surpassing many obstacles, by pushing ahead. And there are issues in the road. For example, the global dearth of software development talent is affecting the EU. There is also a shortage of human resources with adequate skills, specialized IT, and internet experts. And when we talk about skills, we mean adequate skills. Skills that concentrate not only in knowing how to code, but also in knowing how to use open source deliverables to avoid having to code too much. Understanding and creating algorithms is now one part of the programming. The other part is integrating already available existing source code, existing libraries into developed applications. Should a programmer who is actually building a device for controlling access to a car parking spend hours in developing an algorithm to detect if a license plate is in the image that the camera is showing, or should just use a function in an artificial intelligence library which is called and it just gives back the number of the plate? What is easier? Well, it's evident, and that's a big change for teaching IT. No longer algorithms, but also libraries. But let's go back to the economy in general. Vendor locks-in have happened all over the history of economics. And not by having happened all over, this means that they were positive. The Commission is committed to provide EU citizens and businesses with competitive markets, where they can obtain the best products and services at the optimal price. And here again, open source is a fantastic tool to ensure that there are certain sectors continue to have competitive pressure inside. The ICT sector has not been immune to locks-in, and strong political steps have been taken in the past in the software sector. It is also fair to say that the situation today is far different than during the last decade. Competition law in the EU has been successfully implemented and will continue to be if it becomes necessary. In the meantime, the Commission is engaged in setting adequate ex-ante tools so that the competition keeps driving the market forward. Numerous technology trends will have a major impact on the development of ICT. The digital transformation, big data, mobility, social collaboration, blockchain, DevOps, cloud computing, cybersecurity, the Internet of Things. Open source is a powerful tool to bring dynamism to markets and enhance the possibilities of innovators. The European Commission takes very serious having a competitive landscape on the continent, and the EU, as a global player in the front line of the software industry, is taking steps to maximize the positive impact of any trend in our economy. As a prime industrial differentiator and the basis for a growing range of new products and services, open source significantly increases Europe's competitiveness and may largely contribute to Europe's future growth and welfare. The European Commission is committed to invest in ICT, as it has done through the LAID program. The IT research and especially IT-related new and emerging technologies are crucial in order to keep Europe's industry competitive. And that was all from me. Now I expect a very fruitful discussion, and many thanks for your attention.
We start with the ecosystem session. This session looks at open source from an ecosystem perspective. Beyond software development and licensing, open source comes with issues of business model, sustainability, and licensing. This is what this session is about. The next talk is by Vivienne Devaney and Claire O'Donoghue. Vivian and Claire participated in an analysis of the open source ecosystem across all 28 European countries. And this is a synthesis of open source throughout the European Union, trends and strengths and best practices.
Hello all and welcome to our presentation for today's OW2 online conference. My name is Claire and today I'll be joined by my colleague Vivian from the Open Source Observatory team of the European Commission to talk about open source software policies across Europe. Thank you to OW2 for hosting us. Before diving into our overview on open source software policies across Europe, we will start by giving a little bit of background information about OZOR and what it is that we do. The Open Source Observatory, also known as OZOR, is a European Commission project hosted on the JoinUp collaborative platform. OZOR serves as a middle ground to connect European public administrations with other relevant stakeholders involved or interested in open source. It also continuously supports the dynamic community and promotes the use of open source software in the public sector. The general aim here is to be a trustworthy observatory providing open source software expertise and information. The content on OZOR is quite varied, including monthly newsletters, event listings for OZOR and other open source software events, and news about the latest developments in open source in the public sector. That being said, we're not just an observatory. OZOR strives to play an active role in the open source community by promoting open source software and helping European countries with its adoption. We regularly organise events ourselves and attend relevant events in Europe, such as this OW2 online conference. By doing this, we are constantly working to develop closer ties to the community and to keep OZOR relevant to your needs. OZOR also hosts the Knowledge Centre, which has been a key priority this year. The Knowledge Centre's content is continuously updated and includes case studies on the deployment of open source software within public administrations and country intelligence on open source software policies and initiatives within European countries. It will soon be enriched by guidelines for creating sustainable open source communities within public administrations. The open source software country intelligence reports are a key feature of the Knowledge Centre. The reports detail governance, political and legal frameworks, and any major ongoing initiatives pertaining to open source software in the 27 EU member states and the United Kingdom. Our initial desk research findings are being validated by national contact points, providing expert feedback on the status of open source software policies in their home country. At present, the publication of the reports is ongoing, but we are happy to share our findings from all 28 countries today. Let's move on to the core of this presentation, a brief overview of open source software policies in 28 European countries. Please bear in mind that this is not a full analysis, rather an inventory of two aspects: public sector bodies addressing open source software and political and legal initiatives specifically addressing open source software across Europe. We will publish a more detailed report within the next 3 months. When we look at the map, we can see that 9 countries in total, ranging from dark blue to light blue, have one or more public sector bodies that address open source software explicitly from a policy-making perspective. The countries shaded in gray do not have a public sector body that addresses open source software explicitly. The role of these bodies with regard to open source software was found to vary, encompassing broad-ranging functions like coordination, implementation, support, endorsement, and policy making. There is one country with 3 public sector bodies, which is Belgium, where we identified the Flemish, Walloon, and Central entities. The singular body in each region has the responsibility of acting as a torchbearer in addressing open source software. In countries where 2 public sector bodies address open source software, these bodies may have varying roles. In Sweden, for example, the Agency for Digital Government is responsible for the functions related to policy making and adoption of open source software. Meanwhile, the Swedish National Procurement Services, with various initiatives, endorses and promotes the use of open source software. In Denmark, the UK, and France, one body is responsible for open source software, playing a leading role, working to implement and support open source software in their public administrations. For instance, the French Etalab within the Interministerial Directorate for Digital Services, or DINEM, works to implement open source software throughout government administrations and coordinates these efforts.
Our research found that while some countries have multiple bodies responsible for open source software, the functions of these bodies do not overlap. Rather, the clearly defined role of each body seems to ensure that their work is complementary. We have just looked at the number and roles of public sector bodies with regard to open source software. This slide shows the specific breakdown of the types of entities that we identified. So there are 6 agencies in total, all of which are responsible for the oversight and administration of all policy matters pertaining to the digitalization of government. Open source software falls within their remit. Ministries are comprised of various offices, directorates, secretariats, and others. Within ministries, we identify 6 entities addressing open source software. When looking more closely, for instance, within the French DINAM, Etalab is active in supporting French administrations in the opening of their source codes and the use of open source software. Etalab also hosts a repository of open source software that can be used by public administrations. In Italy, the Ministry of Technological Innovation and Digitalization has entrusted the Digital Transformation Department responsibility for open source software. One core project of the department is the Developers Italia website, run by a community dedicated to the development of open source software solutions for Italian public services. Our research identified 4 services in Belgium, Spain, Sweden, and the UK. For example, the Spanish Technology Transfer Center is a directory of reusable applications and solutions available to all Spanish public administrations. Now, I would like you to take a look at the 2 post-its clarifying our definitions of legal and political initiatives. Legal initiatives are parliamentary resolutions, laws, directives, and decrees, and all of them are legally binding. Political initiatives are guidelines, declarations, governmental programs, and strategies which are not legally binding. The map offers an insight into the country's legal and political framework for open source software. We identified 14 countries which have political and legal initiatives specifically addressing open source software. 11 further countries were found to have political and legal frameworks that address open source software within the broad digitalization initiative. As per our research, 3 countries do not seem to have any political or legal initiatives addressing open source software. We identified a total of 94 initiatives, of which 26 focus specifically on open source software, which represents 28%. These are in the countries shown in dark blue. The countries in light blue were identified as having published national strategies or digital services acts that include the promotion of open source software in public administrations, among others. Based on our research, these political and legal initiatives are usually part of the general digitalization efforts of countries. Here, we have clustered the most common domains that the initiatives address. For legal initiatives, we have identified 2 main clusters. The cluster on the development and use of open source software solutions consists of the legal initiatives that we identified that encourage public administrations to create their own open source software for internal use. We found 2 pieces of such legislation in France. The decree specifies the types of open source software licenses that can be used for administrative documents that are communicable and reusable, and the 2012 Aero Circular defined general guidelines for the use of open source software in public administrations. The cluster on the adoption of open source software includes specific solutions that public administrations should adopt, or specific guidelines on how this should be done as part of their policies or action plans. Based on our research, we consider this to be a key cluster for open source software because the initiatives in this cluster call on public administrations to implement open source software. As an example, in 2013, the Italian Code of Digital Administration made it mandatory for Italy's public administrations to use open source solutions, as well as to first consider reusing already developed solutions. Let's now look at the political initiatives. Based on our findings, there seem to be many more political initiatives than legal ones, as demonstrated by the numbers next to the clusters. These findings lead to the emergence of 2 new clusters. We chose to showcase some of the most recent initiatives. The open source software and procurement cluster highlights national documents that, based on our findings, set guidelines on how to fairly include open source software in public tenders, and fairly consider open source against proprietary software, for example. In 2019, Italy's Agency for Digitalization published guidelines on the acquisition and reuse of software in public administration. These guidelines provide instructions on the reuse of open source software solutions and standards and correctly choosing them according to needs. The cluster on the promotion of open source software includes the various political initiatives that we identified that call on public administrations to use open source software without, however, providing a specific program on how to achieve this. For instance, the Open Source Software Policy of 2019 was published by the Malta Information Technology Agency. It encourages the adoption of cost-effective open source software solutions throughout the Maltese public administrations, and licensing under EUPL is also favored. Within the development cluster, the 2018 French Contribution Policy for Free Software of the State defines the conditions for public servants looking to contribute to open source software created by third parties and encourages the publication of new software developed by the government. Looking at the cluster on the adoption of open source software, we see that Denmark's Aarhus municipality published an action plan in 2014. The municipality adopted this action plan as a continuation of its efforts to develop open source policy.
After the overview from Vivian, you might well be wondering, what's going to happen next? Firstly, we will publish all country intelligence reports by the end of June 2020 and gather additional feedback by email. Additionally, we aim to publish the full consolidated overview on the status of open source policies in European countries, so keep your eyes peeled for this report. Please do not hesitate to get in contact if you have any feedback or thoughts to share with us. All of our details are listed here, and we will be happy to hear from community members. The OZOR team would just like to thank you for attending today's online presentation. We hope it was interesting and that you'll join us on the OZOR community in the near future. Before we wrap up, there are just two more things to address. Here, we have a list of all the contributors to the OZOR team. Today's presentation was brought to you by Vivian and Claire, but please feel free to reach out to any of us individually if you have any queries or feedback. And finally, we're all aware why the OW2 conference is currently taking place online, and in this regard, the OZOR team has also been contributing to another initiative of the European Commission Interoperability Unit. Digital Response to COVID-19 is a new repository on JoinUp. It is a live project which is updated on a regular basis, and it relies on your contribution. Contact us if you know any initiatives helping to fight against COVID-19. That's it for today. Thank you again for joining us, and we hope to see you on OZOR soon.
And our next speaker is Ludovic Dubost. Open source is all over the information system. This is what we call full stack open source. Ludovic founded XWiki, and he shares with us the experience of running an open source business model in the context of an end user application.
Welcome to Can End User Apps Be Open Source at the OW2online 2020 conference. I'm very happy to participate to this first online conference, and I hope you're having a great time at home. So who am I? I'm Ludovic Dubost, CEO and founder of XWiki. We've been developing at XWiki the XWiki software for more than 15 years. This software is a collaborative software allowing you to help organize your information. We're also building the CryptPad software, which is an innovative software allowing to collaborate in real time and edit documents while these documents are fully end-to-end encrypted. It's a system that will protect your information. All our developments in the last 15 years have been open source, and we've been developing the business of XWiki so that we can sustain the development of this software. So first, I'd like to point out that open source is quite strong. We have the feeling that open source is everywhere. Open source is the key of the internet infrastructure. It's also completely prevalent for development tools and libraries. And we can see that actually most proprietary software today do love open source and are built on top of them. However, if you look a little bit at the financials, and if you consider that there is a $1 trillion tech industry, and a lot of them being developers, well, when we try to analyze the open source businesses and whether it is open source being developed by the large tech giants, or whether it is open source developed by commercial open source companies, and then we get to some level around 10 billion, and it's not easy to get further than that. And if you look at donations to open source developers, then we're still in the million or tens of millions of dollars. And this actually represents just one store of the big tower that represents that tech industry. We can also actually see that there is a ceiling for end user apps. So while we have a lot of development tools and we have a lot of infrastructure systems that are very strong with open source, well, when it comes to end user apps, we see that they compete with a lot of cloud services, which themselves are using a lot of open source code but are not open source themselves. And this competition has the effect today that a lot of these applications are actually provided by cloud or proprietary providers. So there is a domination of the cloud and proprietary providers when it comes to end user apps. So I won't go too much in the details why we need open source end user apps. We're all here convinced that this is what we want. I mean, there is control, there is sovereignty, there is openness, flexibility, and freedom, and it's not the subject of the presentation today. What I want to look at is the differences of the business model of the cloud and proprietary software business and the open source ones. Well, if we analyze the proprietary software provider, so you have a few providers that are collaborating on some open source code, mostly libraries or development tools, and they are providing high margin services to customers based a lot on proprietary code or on cloud services that they provide. You also have sometimes open source companies that work on the same libraries and try to get some revenue or get some revenue from this company or from end user company that are using the software, which makes that the open source community around the open source code is quite vibrant, but it represents a small fraction of the actual value that is provided to customers. When we look at an end user open source app business model that is providing an app directly to customers, you realize that it's not multiple companies that work off the same code base. It's often one company, which is the main contributor to the open source code, and there are not that many alternate contributors to that code. So sometimes that company has proprietary or paying modules, which represents a fraction of the value add compared to the open source code. That open source code is also used directly by open source users for free. And the open source company is making revenue directly with customers that are transforming from the open source users. Well, the open source code can also be used by other company, cloud or proprietary software companies. This creates 4 questions that make it not necessarily easy for the open source company. The first question is, are open source users actually contributing or buying services? The second one is, can all other open source companies join and contribute to the same code? Third question is, can cloud providers be partners or are they competitors? The fourth question is, how big is the proprietary code in the offer of the open source company in order to be able to sustain the open source business? So if we look, these 4 questions make it a challenging business for open source companies to compete with the cloud SaaS services. If we summarize, it's harder to get contributors and sell services to end user. You have less companies building on the same code base. You need to rely more on paying products to finance the code and scale, and cloud hosters can potentially compete with your own software. How can we actually fix that? The first problem is, are open source users contributing? Well, this raises a question for open source users that if they want more open source app, they need to question themselves, how is that open source company living and who is producing that software? And one way or another, they need to find a way to contribute to that free software. Public administration actually do, because they help fund a lot of open source R&D through French or European projects. At XWiki, we've been very happy, both for XWiki and CryptPad, to be able to have some funding from public entities. So one way for end users, for users to contribute to the software is to contribute to the community itself, participate to the community. This is the essence of open source. Open community, you can come and help with the software. You can also sponsor a feature. At XWiki, we've had a lot of sponsorship of feature, and this is quite interesting to fund the R&D. But these type of funding, they don't help maintain a long-term funding of the open source developers. And this is what support or extensions can help. And so as an end user, if you pay support or buy extensions, then you will help fund the open source code. And the fourth way, which is more rare, is donate, but it's something that is developing with Open Collective, for example. Now, the second question is, can other open source software companies contribute? So is there a way for the different open source companies that work together in the same ecosystem to potentially work together? So first, if you're a company, and if you're a service company, or if you're a development company, then you can pay support, or you can buy pro version or sell pro versions to your customer. You can also donate. The same things that apply for the end user can also apply for an intermediary or another developer that would work with the same code base. Open source companies should integrate with other open source apps, so there can be partnerships between the open source companies so that it's possible to provide a bigger offering instead of potentially competing with each other. You can contribute to the community. And another aspect is that there could be stricter licenses also to protect the whole open source ecosystem from the non-open source ones, which could use the same code base. So the use of stricter licenses like AGPL can help give the open source software industry some advantage over the non-open source industry by the fact that each other, they can reuse the software of the other open source users. Another thing that hasn't been really worked on is how can you share business towards the upstream open source code. So if an open source developer is reusing another open source tool, how can they share the value with the different providers of the open source code? The third question was, can cloud providers be partners of competitors? We've seen that cloud providers can actually decide to be competitors, but if they do, they will destroy the ecosystem. So we need some way where it's going to be more a win-win between cloud providers and open source providers, and cloud providers need to support open source apps. And one very interesting way to actually do that is to develop marketplaces of open source software. It would be really valuable to have a marketplace which will bring back support revenue or paying revenue to the developers of the open source software, and not only revenue to the cloud providers through the hosting. And the stricter licenses and paying module here are also potentially a protections towards the cloud providers that would not work together with the open source developer to create a win-win situation in terms of what is being provided. Another aspect is that the marketplace could also be very interesting for public administration to provide open source software to the public administration and also bring back some revenue to the initial developer of the open source software. For the fourth question is, how big is the paying service box? So what is for sure is that paying services are key to fund open source code. If you only fund a software developer using pure services, pure development services, it's going to be almost impossible to scale. And it's going to be hard to build very advanced end user software. And for sure, not everything can be free. If everything is free and all users are using everything for free, then there's going to be an impossibility at some point to finance the software. The only way to finance it will be to pay for certain specific modules, but maintenance will never be financed, for example. And here, now what I want to point out is that it's not necessarily necessary here to make these paying package proprietary software. It is possible to make paying packages that are open source themselves. And this is a choice that we have decided to do at XWiki, where all our software is open source under the same license, LGPL, but we're not packaging these modules and these extensions to XWiki for free. We're packaging them paying on our extension repository and selling these extensions. But if other providers want to come work with us on the code, then it's possible because everything is open source. It's important also for the open source provider to control the level of non-open source R&D. At some point, if your amount of R&D is going in majority to proprietary software or to services for selling, then you're not really an open source provider anymore. And this is where transparency is actually quite important. I think open source companies should bring more transparency to how they make business and what amount of R&D they're spending for which part of the business, and to show that they are a provider that has the objective of sustaining the open source model. What I want everybody to remember is that open source apps cannot be fully free, because it's going to be very difficult to develop them, and that one way or another, users need to support them. You can contact me by email, or you can also use our software on xwiki.org or crypt.fr, and you can also support us on Open Collective. Thank you very much, and have a great OW2 online conference.
And our next speaker, Italo Vignoli from the Document Foundation. Here, a great success story of our ecosystem. We at OW2 are great fans of LibreOffice, and Italio was part of this adventure right from the beginning, Here to the 10th anniversary of LibreOffice.
Hello, this is Italo Fignoli from the Document Foundation. Today I'm going to talk to you about the 10th anniversary of LibreOffice and the story of the global FOSS community. On July 19, 2000, Sun announced OpenOffice.org. 10 years after, September 28, 2010, the OpenOffice.org community announced LibreOffice. At the time, OpenOffice.org was acquired by Oracle within the acquisition of Sun Microsystem, and it was clear since day one that it was not a strategic product from Oracle. So the community decided that it was time to create its own project and its own foundation. So we announced the Document Foundation because we wanted to drive the product ourselves. As community members, we wanted enterprises within the community, but we wanted the community to be on the driving seat. We chose the brand LibreOffice because Oracle and IBM at the time refused to give the community the OpenOffice.org brand. We relaunched the innovation, exactly what is portrayed in this graphic. OpenOffice was under the risk of abandon. We relaunched the software. We decided to innovate it and improve it over the years. This is a research from a Swedish university, and it shows on the left what happened 10 months before the fork, and on the right 10 months after the fork in terms of contribution. As you can see, the fork was originating a diversity in the community that was not there before, as Sun was really in control of the entire project, not only in terms of development, but also in terms of managing the community. So we decided that our founding principles were the copyleft license, no contributor agreement, meritocracy, community governance, and vendor independence. After 10 years, we can say that these were a very good choice because they have allowed LibreOffice to grow, the Document Foundation to grow. This is the first website of the Document Foundation. It's a little bit old according to current visual habits, but it's still valid in terms of contents. We wanted a self-governing meritocratic entity created by the community. And of course, without the developers, we couldn't have LibreOffice. So let's see what the developers have done over the years. First of all, they've created the concept of the easy acts. The LibreOffice code is 7 million lines of code, so it's not easy to deal with, especially for a newcomer. So developers have fractioned the challenges in small hacks that were accessible even to young developers. And this has allowed, as you can see from this chart, a fast growth of the number of developers. Each month, we were able to attract new developers. Of course, in October 2010, as you can see, we attracted a very large number of people that were excited by the announcement. But then we were able to attract them over the years, every month, for 10 years. And this is an extraordinary achievement if you think that in the past, the code of OpenOffice was thought to be very difficult to deal with. Developers have created unit tests to improve the quality of the product. As you can see, there has been a growth in unit tests and asserts over time. They have, and not only developers, but also volunteers, have translated German comments in the source code to English to make the source code more accessible to a global community of developers. So, in general, in 10 years, we have achieved a reduced footprint of the software. We have renovated the code, removed useless lines of dead code, deprecated libraries, translated German comments to English, and also used a better C++ construct, which are more modern than in the past. In general, we have paid a substantial technical debt that was there in 2010. In terms of organization over the last 2 years, this is the split of commit on Gits. As you can see, there are a couple of companies contributing a significant amount of code, but also a significant amount of code is contributed by volunteers. And this makes the project healthy, because we don't rely, as in the past, for over 60% to a single company. We use automatic security and quality tools when possible. So this is the scan of Coverity. When we achieved the record zero defect, we still are at a 0.00 defect density, which is extremely important, because you have a solid source code to build on. We also use fuzzing tools. This is Google OS Fuzz, but we use others, as you can see from this chart. Over the years, we have used different fuzzing tools to discover vulnerabilities, to discover weaknesses in the code. And of course, without the community, developers would not be able to bring the software to the global community of users. So this chart is from the dashboard, the LibreOffice dashboard, and shows the number of questions and comments on Ask LibreOffice. There is over the last 2 years, over the last couple of years, there is a continuous flow of questions and a continuous flow of answers. This is all managed by volunteers. And this, always from the dashboard, gives you an overview of the community activity. The bar on the right is about the core committers. Then you have the regular ones, and then you have the casual ones. As you can see, there is a stable number of contributors over the months. Of course, there are fluctuations due to the seasonality in some cases. In terms of numbers, the core contributors are producing around 80% of the code, and the regular one around 15%, and the casual one about the remaining 6%. So in general, the community is healthy. We are able to produce a software which is backed by a community, and the community is really global. This is a map of where in dark green you can see the community member, the countries where there are community members, and in light green the countries where there is a community active on LibreOffice, but not specific community members. We have now some additional countries where there are members, but the situation is evolving, and the number of members is increasing. Localization teams are growing. We use WebLate. We moved from Poodle recently. We have 145 active languages, and around 120 are shipped. There are over 4,500 users and over 400,000 translations. This makes LibreOffice as probably the software available in the highest number of languages, and it's important because this also is protecting some native languages that are under risk of extinctions. In these cases, we try to provide a localized version of LibreOffice. In terms of users, these are estimates based on the global number of PC users, which are between 2 and 3 billions, 90% Windows, 80% macOS, and 2% Linux. We have 100% of desktop Linux users, 10% of desktop Windows users, and 10% of desktop macOS users. In general, this accounts for over 250 million users now, but we consider 200 million to be conservative in terms of numbers. The increase with the recent situation of the virus spreading around the world, we have seen an increase of downloads. Is probably the number of users has increased because many users that were not using an Office suite at home have probably decided to download LibreOffice for their personal and in some cases for their work activity. These are donations. The project is backed by donations. We have a number of over 60,000 donors per year, and we are close to 1 million euro in terms of amount. Donations also have slightly increased with the current unfortunate situation. LibreOffice is the product is available in 2 versions. LibreOffice Fresh, which is the latest version. We suggest it to power users, to people that are willing to test and use the latest feature. Of course, might be in some cases slightly less stable than LibreOffice Still, which is the previous version, is also available in a long-term supported version. We suggest it to enterprises and it's backed by professional support provided by certified individuals. Of course, support and LTS version, which are provided by the ISU companies, are not for free because they assume that there is a professional activity behind. That's all. I hope you have enjoyed the presentation. Our dream is that at a certain point we will win. I'm sure that together we will do. Thank you very much. These are my personal and work email. I'm happy to answer your questions if you have some. Thank you, and hopefully goodbye to next year in person.
Our next speaker, Toby Lango. Toby is an open source strategy consultant whose clients include Google, Intel, Microsoft, and Mozilla. In these talks, he explores strategies to fund open source and make it more sustainable.
Are you familiar with this logo? It's the logo of the Heartbleed bug. The Heartbleed bug, a critical bug to OpenSSL, the library responsible for cryptography for a huge portion of the web. This bug by itself cost the industry roughly $500 million, among other issues, like compromising the confidentiality of over 4.4 million US patient records. It was a pivotal moment for the tech industry where it realized that open source was ubiquitous, critical, and grossly underfunded. At the time of the bug, OpenSSL had a single maintainer operating on a shoestring budget of $2,000 per year. This led the industry to really consider sustainability of open source infrastructure on which it depended as a critical issue. And in order to try to fix the problem, a number of efforts were launched. One of the first one was the Core Infrastructure Initiative that was organized by the Linux Foundation. It was a multi-million-dollar fund whose goal was to harden the security of key open source projects. The focus of the Core Infrastructure Initiative, however, was very much to prevent a new Heartbleed and not to make open source as a whole more sustainable. So maintainers took matters in their own hands. Notably, Evan You, who leveraged Patreon, the site originally aimed at artists, musicians, and writers, to create a meaningful revenue stream for himself so that he could work on Vue.js full-time. He was able to make roughly $17,000 per month from patrons. But unfortunately, this model hasn't really been reproduced by other maintainers, or at least not successful at that level of success. Another initiative that tries to make open source more sustainable is Gitcoin. So Gitcoin is first a GitHub issue market that allows project owners to add bounties to GitHub issues, and devs then get to submit their work as pull request. It has distributed in 2018 $500,000 of bounties. And what's interesting is it's a whole ecosystem which includes an ad network called CodeFund. The point of CodeFund is to allow open source maintainers to add contextual ads to their open source projects, essentially focused on hiring other developers, right? CodeFund has been making roughly $10,000 in monthly revenue and has been able to redistribute about 60% of those. Open source has also been taken notice by venture capitalists. And there's even a dedicated fund right now called OSS Capital that funds companies that are building their business on top of an open source project. Another really interesting initiative is Open Collective. Open Collective is a startup that provides nonprofit status to open source projects which otherwise don't have a legal status. And it also helps providing transparency as to how funds are used. Its biggest success story to date is Webpack, which has reached in 2018 $400,000 in yearly funding and has that increase ever since. It does, however, suffer from a long tail project. In 2017, a quarter of total funds were actually given to Webpack. And so to fight that, Open Collective has created Back Your Stack, a software that lets companies not only understand what open source projects they're directly relying on, but also the recursive dependencies of those projects. That's very similar to what Tidelift, yet another project, is trying to do. Tidelift is essentially Red Hat business model, but for the long tail. It provides security updates, maintenance, and legal assurance for all open source projects in an organization's stack. And it does that by actually paying the maintainers of these projects to do the work. It's a lot nearer though, so we don't have a good success story to share yet. Warning ahead though, all of these different efforts really can't by themselves address the whole issue of sustainability of open source. And that's because there just are limits to what we can do with funding alone. And we'll look at 4 of those key limits. The first one is whether funding actually scales all of the way that we want it to. The second one is whether money is actually the problem. The third one is whether we're funding to work would and be able to fund open source by itself. Would that be a desirable outcome in itself? And lastly, we'll look at what the real value of open source actually is and whether we're not really leaving money on the table by focusing more on code than on every other aspect of open source. So let's get started with scaling first. This is $100 bills, $100 bill. If you stack 100 of those together, you get $10,000, which is the monthly revenue of CodeFund, the ad network I mentioned earlier. 100 of those, and you get a pile that's worth $1 million. That is the amount collected by Open Collective in a year, roughly, and is also the amount that Titleist has committed to pay back developers off of the $20 million that it received in funding. Let's compare that to open source developers to the worldwide population of developers. Roughly speaking, we have 12 million full-time developers, about 6 million part-time, and roughly another 4 million that are non-professional. If we do quick back of the envelope math, we'll realize that if we account for $65,000 for $65,000 for annual salary for the 12 million full-time developers and $35,000 for the 6 million part-time developers, we're roughly at an envelope of $1 trillion in wages only, not accounting for anything else for developers worldwide. Now, let's compare that to the $1 million that we're actually spending on open source and put those two in perspective. So if we take 100 times $1 million and put that on the pallet, we get $100 million. Take 10 pallets together, and we're now at $1 billion. Build a 10 by 10 square of pallets, and we have $10 billion. To get to $1 trillion and watch the truck for scale, we actually have to stack 100 of those on top of each other. And that gives us $1 trillion. If we go back to compare it to the $1 million that Open Collective is giving open source, for example, that Titleist is committed to give back to maintainers, we realize the huge discrepancy that there is between the money that's spent on open source compared to the money that is used to pay developers worldwide. Let's now look at the second question, is whether money is even what's missing. And there's a really interesting chart here that shows us the percentage of Linux kernel developers that are employed full-time to work on Linux kernel. And we realize that this is more than the vast majority. This is like close to everybody. And so this is extreme for the Linux kernel, but this is a data point that we can see across the board. The problem isn't money. The problem is time spent by developers working on open source. All right, let's ask the third question, which is, would that even be a desirable outcome? right? Do we want a future with charity-funded open source developers on one side and corporate developers writing glue code on the other? And I think there's a really interesting answer from DHH, the creator of Ruby on Rails, on this. And I'm just going to read an article, part of an article he wrote in 2013. Part of the reason much of open source is so good and often so superior to closed source commercial projects is the natural boundary of constraints. If you're not being paid or otherwise compensated directly for your work, you're less likely to needlessly embellish it. You're solving the problems for you and your mates, likely in the simplest way you could, so you can get back to whatever you originally intended to do before starting to shave the yak. So basically what DHH is saying here is that there's clear benefits to actually having engineers work on open source rather than rely on someone else to be building open source software for them. Which brings me to my fourth and last point. What is the real value of open source? And how we're leaving money on the table by optimizing for the wrong thing here. So the way we tend to think about open source is we'll look at corporations on one side and open source developers on the other, and we just assume that corporations are using open source software, and that's it. And so when we have a sustainability issue, we just essentially expect corporations to throw money at the project to fund the open source software. And get the developers to contribute more so that the corporations can then leverage that value more effectively and better. In practice, though, anyone that's been paying a bit of attention to open source realizes that the real value, the real strength of open source is in the community and the relationships and the byproducts of those relationships and of that work that happen within the contributors, right? And so in practice, while corporations believe that they're actually benefiting from open source and really capturing its value, well, that value is going away with these open source developers, bringing that value back with them to the companies that they're working with. And so the question then becomes, well, how do you capture that value? And the answer is to stop looking at corporations as like entities, but to realize that they're actually full of developers themselves, right? And not only can those developers contribute to open source, they can also benefit from that incredible network and the community that is built around an open source project. And that is how they can then bring back value to their own company through best practices, improved understanding of the software that they use, leveled up engineers, etc., etc. So, in conclusion, what we can say is that charity-like funding of open source alone is not the solution. The real way forward is to normalize engineers contributing to open source as part of their day job. How do we do this? We do this by making organizations understand better the return on investment of contributing to open source. Thank you all for your attention.
And the next speaker, Claire Tona, Funding Box. In this presentation, Claire tells us about funding opportunities from the European Commission for projects that aim at changing the fabric of the Internet and the web.
Hi, my name is Claire and I'm a project manager at Funding Box, one of the partners of the NGI Pointer project. Today I'll be talking to you about the NGI Pointer project and how to apply for funding for your bottom-up project. For those of you who don't know, the Next Generation Internet is an initiative designed to support the growth of a human-focused internet. A human-focused internet has key European values at its heart, such as openness, inclusivity, transparency, privacy, cooperation, and protection of data. To date, there have been over 1,000 proposals submitted to the open calls made available by NGI projects, represented by over 30 countries in Europe. There have also been over 200 projects funded. NGI Pointer is one of many NGI projects. It also has funding for bottom-up projects, 5.6 million euros to be exact. We are looking to fund bottom-up projects that are within the scope of the Internet architecture, web components, and tools and methods. We have already closed one call on the 1st of June, but we expect the second call to launch in April 2021. We will be awarding up to 200,000 euros in funding per project with a 12-month support program. But before you start, I encourage you to read the Guide for Applicants, which explains the eligibility criteria. You can find this guide via the link in the slide taken from our website. In NGI Pointer, we're very much focusing on people. We are looking to support the best individuals, such as European-based researchers, developers, hackers, internet activists, as well as entities such as SMEs, startups, universities, NGO. What matters is that you have credible experience in at least two of the following 5 criteria. Experience contributing to open source, experience contributing to the Internet architecture community, experience contributing to scientific publications in the Internet architecture fields, experience contributing to an Internet or web SME or startup with European values, and experience contributing to the Internet and web communities through other means. NGI Pointer also has a work program that suggests 9 areas for your bottom-up project. These range from privacy by design to network optimization, autonomous network operations, energy efficiency, and so on and so forth. But these are just for guidance. You are welcome to develop projects in related areas that will contribute to the renovation of the Internet. Now, as I mentioned, I am from Funding Box, and we are the partner responsible for the open calls. We have our open call management system, which I will explain to you in a bit. And I will also take you through the application process, which is very intuitive and easy to use. To get started with this process, all you need to do is create a Funding Box account so that you can access the platform where the application form is hosted. And then you will need to click Apply Now, followed by Start an Application. So as you can see, there are a list of compulsory sections which you will need to complete. We ask for basic information about you and your team, information related to your project and other relevant information as well. It is all online and you can even come back in your own time to complete the application at a later point. And importantly, there is no need to process any paperwork until you are selected for funding. On top of that, you can export the application as a PDF. And in the scenario that you create more than one application, for instance, if you want to create a test application, you are able to delete the application that you do not plan to submit by clicking Delete this application. Remember that only one application can be submitted per team, and it's the first application that is submitted that will be evaluated. So to summarize, it's a very straightforward process. You first need to sign up, and then you click Apply, followed by Start a new application. You then have to fill out all the fields, and then click Submit. The proposal itself should take you only about a day to a day and a half to complete. So we've really tried to streamline the process as much as possible for you. So just some very helpful things to remember. As I mentioned, only the first submitted proposal will be evaluated, so make sure you submit the correct proposal and delete any unwanted proposals. You can also edit after you submit the proposal. You can add a contributor to help you fill out the application. So this could be a member of your team. You can only submit once you have filled out all the compulsory fields. So if you don't fill out all the compulsory fields, the submit button will be grayed out. And finally, remember to submit before the deadline, because anything that comes after the deadline is not considered eligible. If you need any support, we're there to help you. We have a dedicated help desk, so you can reach us via that email address. On top of that, we have a community which you can participate in, run by Funding Box. Once you sign up, you'll be able to introduce yourself, interact with other experts. You'll get up to speed with news and events because we publish on this platform. And you'll also be able to access helpful documents like the open call Q&A. So I'd like to thank you for listening to my presentation. And as I mentioned, feel free to contact us. We're here to help you. And you can visit our website for more information. Thank you and good luck.
Okay, now it's time to take a short break. Of course, the chat channels remain open. And now, our keynote speech. I'm pleased to introduce Roberto Di Cosmo, a great friend and a unique figure in our open source ecosystem. Roberto had a vision that there is much knowledge and culture inserted in software. And this vision helped launch the Software Heritage Foundation.
I'm delighted to take part in this year's edition of OW2Con. Today, we are looking together at the merging of software heritage, which is a revolutionary infrastructure for open source. First of all, let's start with a little bit of a background. Well, a few years ago, Mark Andreessen, in a very popular article, famously wrote, "Software is eating the world." Basically, the meaning is software companies are outperforming and sometimes even buying out other more traditional companies. Well, over the past years, it has become clear that open source is eating the software world. You see open source components all over the place, not just in infrastructure, but in verticals, in business, in application, all over the place. If you look at a survey from Sonatype published a few years ago, that they found that 80 to 90% of every new software application is actually just reuse of components coming from open source libraries or other applications available all over the place. Well, this is a great news because we have to write less and reuse more, and so we can be more flexible, more efficient. But it also comes with quite a lot of challenges. Well, if reuse is a new rule, it means that inside your software application there is so much software you didn't write. You probably don't know. So the big question is, where does this software come from? Well, if you look around, this software comes from a variety of places. On GitHub, you find an incredible amount of software today, but you find source code that comes from so many different other places. From software distribution like Debian, from traditional archive like the C, RAN or CTAN or CPAN, the comprehensive tech or R or Perl archive network, and so many other places. And there are forges all over the place, GitLab, GitLab.com, GitLab instances, the former Google Code, the former Gitorious place. I mean, a lot of different places where software can come from. So the big question for big companies or for any kind of software user or adopter is actually, do you actually know where the software you are embarking your application really comes from? I mean, all kinds of software. The software you sell, the software you use, the software you buy, the software that has this or that bug or vulnerability. So the big question is, we need to know. It is not a black box, it is a white box. And so there is no excuse for not knowing where this comes from. And so, there are good practices that are emerging, like in a banking industry, you find this famous KYC principle, know your customer. Well, in software, I really think the time has come for the KYSW principle, the know your software principle. This is essential all over IT. But for knowing where your software comes from, well, actually, you see, there are so many places where the software has been found, and you see all over this place here, where did your software come from? Where it has appeared first? Well, to answer this kind of question, we need a common infrastructure that tracks all of the open source software around the world. Not just the one which is on one particular platform, but the software comes from all over the places. Well, the good news today is actually such an infrastructure is being built. Actually, we have been building this infrastructure for over 5 years now, and the name of this infrastructure is Software Heritage. It has not been designed just in principle for answering IT industry needs. It turns out, nonetheless, that as any essential infrastructure, it can cater to the need of many, including those of the IT industry. Well, let's meet Software Heritage. Well, Software Heritage, in a nutshell, is a unique initiative that has been designed from the beginning to actually collect, preserve, and share the source code of all the software ever built. These are the key principles of this initiative. And of course, the goal is preserving the original software from the 60s, 50s, and all the decades that have passed, where we have seen the emergence of the technology that is revolutionizing the world, but also, even more so, to better understand how software is built today and prepare better software and better science for all tomorrow. In a nutshell, again, what Software Heritage is doing is creating a universal reference catalog of all the software around the world. So no matter where it comes from, GitHub or GitLab or cPan or Citan or Debian or Red Hat, etc., you will find it indexed in Software Heritage. It's not only a catalog, though. It is also an archive, a universal archive. Well, when we are talking of archives, let's think a little bit about what it means. We are all used to go to software development platforms, forges, where we work together to develop software. But these things are not archives. We see it very well. For example, if you look on the slide here, you see Google Code here or Gitorious there. They are very popular platforms. They were very popular platforms a few years ago. They have been just discontinued in 2015. 1.5 million of software projects have been endangered and needed to be migrated away. This is because development platforms are not archives. So we need an archive, a place where when you put a piece of software there, you will find it again later on. And this is what we are building. And then, last but not least, we are also building the building blocks of a research infrastructure, a universal common research infrastructure that allows all of us to analyze, to study, to look at the trends in all of the software source code ever built, including the one you are building right now, today. Okay, well, this is actually a long-term undertaking. It is an international non-profit initiative because open source software is a common and must not be handled only by private companies or only by a particular institution. That's the reason why we are bringing together many different organizations under the umbrella of UNESCO that share this vision and that are going to work together to maintain an infrastructure to preserve and make available these commons for the long term. And of course, since this has a cost, everything has a cost, so it's nothing for free, we also have brought together many different stakeholders which are starting to fund and support the development of this infrastructure. Of course, INRIA that started all this 5 years ago under my direction, and many other companies that you can see some of the logos here on this slide today. And by the way, you see there is a lot of white space there, so other logos are pretty welcome. Well, this initiative has been built to protect this commons, which is open source in the long term, but it turns out it is actually a revolutionary infrastructure. Let me try to explain why it is the case. Well, first of all, if you really want to collect everything which is out there, then you need to build an infrastructure which is able to go and track the software developed in all the different places, forges, distribution, package manager, package repositories, collect all these informations. And then once you get all this information, you find all the history of development of this software, which is built using very many different version control systems or package formats. And since we are here for the long term, actually convert the representation of the version control history of the package format into a single universal format, which is technically a gigantic Merkle direct acyclic graph. These are the kind of graphs which are also very popular in distributed version control systems like Git or Mercurial or Bazaar, and which form the basis for cryptocurrencies, blockchains, distributed file systems, and the like. Well, this allows us to keep the full development history permanently archived, and today we have reached over 8 billion unique source files which are archived in Software Heritage, coming from over 120 million different origins, and counting. And well, you see, this is actually a revolutionary infrastructure because on one side we are building this graph of the software development, And this is not any graph. It's actually, as I mentioned before, a Merkle graph, which is the basic of blockchains and which is fundamental for traceability. From this, we also provide specific identifiers which are extremely powerful to track every component. It is also a pillar of open science, but this is would be a subject of full another presentation. And since we put everything into a single uniform graph structure, no matter where the software comes from, no matter what version control system has been used, we are actually building an incredible platform for big data studies, for being able to look at the software massively for quality, cybersecurity, using machine learning, AI, whatever you want. Well, now I would like to zoom in on a few selected industry use cases, which are all built for the moment on one particular feature of software heritage, the ability to provide intrinsic identifiers which are uniform across all kinds of source code. These are the software heritage identifier, or SWID, as we call them, which are built exactly like this. The schema is very simple. It's this prefix SWH that tells you this is a software heritage identifier, a version number, because the schema can evolve over time, then a tag that tells you, this is an identifier for what kind of object type, and then the object identifier, which is basically a cryptographically strong hash that precisely identifies the particular artifact you are interested in. And well, the object type can be many. It is not just a content, it can be a directory, it can be a revision, it can be a release, it can be a full status of the version control system that we call a snapshot. And we can also add context qualifiers that tells you, for example, of this particular file, I'm interested not in all the file, but in this particular line here. And I can also tell you where this file has been found, where it was originated from. And this actually is an emerging standard. The recently published version 2.2 of the Software Package Data Exchange from the Linux Foundation contains SWIDs. And the software identifier SWIDs are registered in IANA and are also properties in Wikidata. Let's try one. You see here, behind this link, there is exactly one of these software identifiers, which are resolvable in software heritage today. You see, we click there, here you have the software identifier, and immediately you are brought precisely in front of the code fragment we are interested in. And this is a beautiful piece of the source code of the Apollo 11 guidance computer. But again, no time to detail this for the moment. Well, these are actually key building blocks for industry use cases. And let me give you a bunch of them. One is open source compliance, a particular case of open source compliance, where one does have to handle the obligation to distribute the complete and corresponding source code of a piece of code. And this is particular use case that came from Intel, which is working with us. So software heritage members can actually archive the source code they want in software heritage and then only distribute the software heritage ID, no longer need to distribute the full source code because the source code will be in software heritage. For traceability and integrity, the Open Invention Network is actually now working with us to make sure the Linux system definition is maintained by actually archiving the source code of the specific components they identify in software heritage and only track the identifiers using the property that SWIDs guarantees the integrity of the content. But there are many more use cases. Other use cases in compliance. In security, there is a collaboration ongoing with the US Department of Commerce, supply chain management, whatever, you can add your use case here. We really suggest that you actually join the software heritage revolution and become a member of this growing community that is supporting the building of this infrastructure, that is using this infrastructure not only for preserving the past, but also for building a kind of a CERN for software, a better infrastructure for building better software for industry, society, and the whole. Thank you for your attention.
The next session is OW2 Project Showcase. It is dedicated to OW2 projects. It's about technology, innovations, and success stories. The presentations selected demonstrate the advanced concept implemented in our project, and they illustrate the value of the OW2 codebase. Our next speaker, Clément Odo, Vortex. Clément is the lead developer of the popular Lemon LDAP system. In this talk, he introduces a new OW2 project, LDAP Synchronization Connector, what it does and how it can help systems administrators better deal with identity management.
Welcome on this presentation about LDAP Synchronization Connector for OW2.com. First, I would like to talk about identity management. Identity management is what we need to manage our accounts inside our information system. So it's very simple. It relies on identity lifecycle. It means you need to take care how you create an account inside your system, how you update this account, and how you delete it. This need to set up some processes and to have some tools in order to manage these identities. It means you want to be able to quickly create an account for a new coworker. So you ask him some information and you put this information inside the system. And depending on this information, your coworker will access to some application or will be able to do some things inside your information system. Of course, the last step is very important. It means when your coworker is leaving your company or organization, you need to be sure that his account is revoked and his accesses are also deleted. Now, LDAP Synchronization Connector is a free software, of course. Is written in Java under BSD license, and is part of OW2 community since last year. You may have already heard about Fusion IAM, which is a collection of tools about identity and access management. So it includes Fusion Directory, it includes LDAP Toolbox, it includes Lemon LDAP NG, and it also includes LSC. And all these projects are now part of OW2 community. So with all these projects, you have a full identity and access management solution. The main features of LDAP Synchronization Connector are the data synchronization between identity rows. It means that this tool is designed to be able to copy your accounts and groups between your identity base. Mostly these warehouses are LDAP directories and SQL databases. We have inside LSC some special function for Active Directory because Active Directory is not really a standard LDAP directory, but with LSC you can automatically create and delete accounts inside Active Directory. LSC also have a powerful plugin engine. And we have a special plugin inside LSC which is called Executable. This plugin can run script to update and delete data inside an application, for example. There is a scripting engine. We will see an example later. And last point, one of the last points is the dry run mode. It's very important. It means you can run your connector, but in a read-only mode. So you will see what would have done the connector before writing your modification. The last point is to say that LSC can be planned. It means you can run it as a cron job. And we also have some real-time synchronization For the moment, only with OpenLDAP as a source directory. LSC will be able to intercept every event of modification inside OpenLDAP and forward this modification to any destination database. Some examples. We use often LSC with human resources databases because we know that all movement of identities are often made inside the human resources database. So we can, with LSC, detect that a new person joins the company and we can automatically create its account inside the enterprise LDAP directory. Some technical stuff between OpenLDAP and Active Directory. We can synchronize all objects between these two referentials. We can also transform dynamic groups into static groups. We can also, thanks to the executable plugin, talk with external web services, include API. So LSC can be used for very different usage. How it works. So this is mainly a command line tool which uses some XML files to configure it. The main configuration file is lsc.xml. You will set your connections inside it and define your tasks, because in one file you can configure several different tasks. For example, one task for user synchronization and one task for group synchronization. And inside this task you will define your synchronization rules. It means you can have a simple rules which say I take the value from source and copy it directly to destination, or you can do some transformation like set the value in uppercase or concatenate the value with another value, etc. You have the standard log configuration with the logback, and for databases we use iBatis, which is a Java software, which also use some XML files to configure it. For the synchronization, we have this process. So LSC will first read all entries from the source, and it will take one attribute, which is the pivot. This attribute will be used to map the source entry with the destination entry. It means you have a value, mostly we have the user identifier, for example. We will compare the user identifier in source with the user identifier in destination. If they match, it means that there is an entry for the user in destination. If LSC cannot find any entry in destination with the pivot value, it means the entry is not yet created, and LSC will create the entry. So LSC read all entries, read attributes, and will then compare all values, calculate modification, and at the end it will apply all these modifications. Of course, it will only write in destination the needed differences between source and destination. So if you run several times the connector will not write anything if there are no modifications inside the source. The second phase is the clean phase, is how you will delete your entry in destination. For this, the first thing that the connector is doing is to list all entries from destination, and for each entry it will search into source to get the corresponding entry thanks to the pivot value. It means if the user is no more in source, LSC will say that this user must be deleted inside destination. What we can see in sync phase and clean phase is that the source is always a read-only database, and all modifications are always done in destination. And to conclude, a small sample of the configuration. It's an advanced usage with some scripting. Here we see that to calculate the member values in destination, we use some script to get all values from the member UID in source, and we'll recreate the correct values in destination. If you want more information, of course, you have some links here about the documentation, some tutorials, and of course all information on OW2 project page, and also source code on GitHub and OW2 GitLab.
Our next speaker is Marco Ballestri, Norwich. Marco leads knowledge development in the big data and advanced analytics, and his talk, he shows how to bridge the gap between data visualization and data science so as to be able to present complex analytics to a broader audience.
Hello everyone and welcome. Thank you for attending this speech in which we will talk about how to boost data visualization with modern technology and in particular with Python. In the next about 10 minutes, I would like to show you how this particular technology, Python, was embedded inside the suite Knowledge. Before starting, I would like to say a few words about me. My name is Marco Balestri and I am a developer at Knowledge Labs. You can find here my references and feel free to write me if you have any questions at all or any doubts. Before diving into the details of the brand new functionalities of Knowledge, let me give you a brief overview of the suite. Let me tell you something about Knowledge, how does it work, what does it do, and what are the goals and the features. First of all, Knowledge is open source and can be found on OW2 Forge. There you can find all the single packages and also the complete installer. Speaking now about the functionalities of Knowledge, I can say that it allows users to retrieve data from multiple data sources, and it combines many analytical capabilities inside one single software. It is accessible via browser or via mobile devices, and the analysis that users make in Knowledge can be easily integrated in external web pages. Okay, this was a quick, brief overview, but given this starting point, the question is, why Python? Well, the two keywords of these new innovations are advanced analytics and big data. The goal is how to use these modern technologies, such as Python, to boost and in order to improve data analysis and visualization. So on one side, we have the large amount of data that various environments give us access to. In particular, Knowledge defines a common interface, which is called dataset, to access and retrieve those data from multiple data sources, like databases, like files, or they can be repositories, and so on. On the other side, instead, we have the necessity of managing and visualizing this data efficiently. And to fulfill this purpose, it is essential for us that we learn how to properly use new technologies like Python. By supporting Python as a programming language, we can exploit the wide range of tools and libraries that, for instance, this language makes available to the final users. We developed the possibility for users to create elements that can be, for instance, widgets or datasets by directly embedding their own Python scripts inside Knowledge. By doing this, programmers or data scientists can define their code, can write their own scripts in order to create their own highly customized and high-performing visualizations. But why is it useful to embed Python code directly inside Knowledge? Well, it is useful because in this way, user can work in a ready environment. They don't have to deal with settings. They don't have to deal with data gathering. They only have to focus on the business logic of the application. Inside the script to be embedded, in fact, the users will have the possibility to access easily all the large amount of data that are already bound to Knowledge. These data are already given by the suite in the form of datasets, and they are already ready to be processed and used. Suppose we have already defined a bunch of datasets. They are based on queries, files, or anything we want. When we write the Python code, we don't have to deal with those readers again because they've already been defined once. So the programmers will have the data already at their disposal without having to write again the code that retrieves them. They don't have to write queries or connection to databases in the code, for instance. And then in the script, they can use all the libraries that Python makes available for users. They can use these libraries that help creating plots or graphs and visualization and so on. And they can use these libraries to exploit the imported data. So combining the power of these two entities, the data, the graphical libraries, and also the freedom and the easy Python syntax, it will be possible to make it quicker and easier to fill the existing gap between data visualization and data science, and also by working in such an intuitive and heterogeneous environment like Knowledge, even people that, let me say, are not so comfortable with coding or programming will have access to the broad universe of big data. So now let's see in play the full power of this new engine embedded with the already existing tools and functionalities. As you can see in this video, we can exploit Python to create highly customized and interactive visualization, and at the same time make it work together with all the traditional data analysis functionalities and components. Tables or selectors and all these elements can interact and modify the output of the visualization made with Python, but the Python code that creates the visualization never changes. It is produced by the user only once when he creates the cockpit, and then it's embedded directly inside the widget and stays the same forever. Once a programmer or a data scientist has defined the script and has created the visualization, everyone else can use his work to visualize data efficiently without having to rewrite the code from scratch. The interface that helps creating these kinds of visualizations is very usable, very intuitive. The user designing the cockpit will have a tab like this one, in which he will have access to the datasets of Knowledge. All he has to do is choose from a selector the dataset that he wants to work with, and then the data will be imported, and the users will also be able to see a preview of this data. And just by doing this simple operation, the connection with data is made, and this data will be available in the Python code. This will avoid losing precious time and sparing a lot of complexity to the programmer, since he will not have to deal with data readers or connections, and data will be already available for him inside a pandas data frame variable, accessible directly in the Python code. In the script editor, the user can write his script, and this code will likely use the data defined before in order to create some visualization upon them. So for instance, here I am defining the Python code that takes those data and produces as output a really simple image containing a bar chart. Of course, in the script, one can use whichever Python library he likes and create all the kind of plots. In fact, this is the real purpose of the widget, giving to the users the freedom to work without any constraints at all on the type of charts or on layouts that has to be produced. Once I click on Save, the Python code is executed by the engine, the output is rendered and visualized inside the cockpit. As you can see, this makes all the process smooth and simple. In just a few clicks, we were able to get data and run the script that creates the chart. And this is something that otherwise would have cost us hours of work if we had to deal with all the process by ourselves. So freedom, versatility, and simplicity are, in my opinion, the three greatest conquerors of this widget. Speaking about technical details, the lightweight architecture of this new feature is based on the existence of a new data mining engine, which is written in Python as well. And this engine runs as a standalone web service. It is a service whose APIs are separated from the no-agement server ones. And of course, the component will be distributed alongside Noage, but will be optional. This service will act as the core of every future Python functionality related to Noage and will be in charge of managing all the data flows between Noage and Python. And most importantly, it will be used, let me say, as a sort of remote code executor for all the scripts that are embedded in widgets and datasets. When we use this new infrastructure, if we monitor the network activity, we can notice a change in the information flow. In fact, the traditional architecture expects the data to flow only between the clients and the Noage server. But when we use Python instead, the data mining engine written in Python works as a proxy between client and server. And this proxy processes requests, executes code, retrieves also data from Noage, and is responsible of returning back to the clients the desired outputs. Though the original data flow will be maintained for all the operations that don't require Python, so for those operations, nothing will change. But instead, when we need Python to perform some tasks, Noage will automatically recognize it and redirect all the requests towards the engine. This idea allows us to treat Python as an optional plugin, and furthermore, it makes both the data mining engine and the Noage server transparent and independent from each other. Alongside the Python engine, we are developing another service to support the same functionalities through R scripts as well. We want data scientists to be able to pick the language that they prefer, might it be Python or R, and provide support for the same functionalities in both languages. So as they do with Python, they will be able to use also R scripts in order to create widgets or datasets. Depending on their skills or on the problem to be solved, the two languages are interchangeable at free will. So at last, the features that I showed you today will be released together with many other interesting news inside the next version of Noage, which will be the 7.2 version and is expected to come out by this summer. This new version, besides Python, includes many other features that expand the gallery of possibility that the Noage suite makes available. We want to expand as far as possible the things that final users can do, but at the same time, keep them easy and useful. Of course, we want to always be ready to accept new technologies, for instance, like Python, and constantly use them to innovate what we already have. Okay, I think we have come to an end. I hope you enjoyed this overview. If you have any question, please don't hesitate to contact us. We will, of course, get back to you as soon as possible. I would also like to remind you to subscribe to our newsletter so we can stay in touch. You can receive all the latest news about the Noage world. Thank you everyone for the attention. I hope to see you soon. Goodbye.
Our next speaker, Vincent Massol, XWiki. Vincent is CTO and co-founder of XWiki. In this talk, he shows how web applications do not need to be developed from scratch, but instead should leverage high-level services platforms from advanced next-generation wikis.
This talk
about XWiki as a web development runtime platform. So I'm Vincent Massol from the XWiki SAS company, and I'm also one of the open source committer on the XWiki project. So today my goal is to try to present XWiki in a different light. Some of you may know it as a wiki, as an advanced wiki, but I would like to show you and demonstrate that you can go further than that and that you can use it as a development platform. So let's start. So what do we have for today? So I want to first to show you that XWiki is not a wiki. It's a lot more than that. Then we'll see what we can develop with XWiki. Then we'll talk about the development model to see how it's done in practice. And we'll conclude with some pros and cons of using it. So why is XWiki not a wiki? So actually it is a wiki, of course, but that's just one usage. So what you're seeing on the screen is an example of using XWiki as a standard wiki. This is what you get if you download it. So by default, it's a structured open source enterprise wiki that is ready to be used. You don't have any development to do, you can just use it as is. But, and that's the important but, it's also a platform for developing any type of content-based web applications. So under the hood, it sits on top of a servlet container, and XWiki exposes a lot of services, more than 700 actually. And those are business services. They're not just technical services like a logging service, but they're also business service like a WYSIWYG editor, the ability to do configuration, the ability to have a blog application, a scheduler, a watch list, skins, attachments, store, etc. Custom metadata, and a lot more. So all those services are exposing APIs that you can actually use yourself. You have access to them. And they also expose, for some of them, they also expose UIs. So wiki pages and UIs. And then your own application can add your own services developed either in Java, for example, or inside wiki pages themselves. And of course, your application can also provide content pages as wiki pages. But you sit on top of this platform and you've got access to those 700 types of services and APIs. So what can you develop with XWiki, knowing this? So I'm going to show you some examples of things that were done using those APIs that I mentioned. So first one is collaborative website. So this is, as you see, it doesn't have a look of a wiki. It looks more like a website. However, when you go on some pages like this one, the one you're seeing, there's a little pencil button, or several actually here, and you can click on edit, for example. And if you do so, then you're actually editing the page, or the wiki page, with some structured data. As you can see, it's not just plain text data. So there is the detailed part is the plain text, but then you've got also the themes, you've got the video part, etc. So this is where you find the wiki engine underneath, but it's completely hidden as a website and with a custom UI. Another example of what you can do with XWiki is another website called Kriki, and which allows to write courses collaboratively. Several teachers can group together and write a course for students. And again, you can see on the screen when you edit a page, the structured concept where you can have a lot of different type of metadata there, and then having some scripts and some UI to present this metadata on screen. Another example is an intranet. So you see yet another look that's very different. Ability to search on the homepage, to list the last items, and then go on a specific page. It doesn't look like a wiki, but you still have the edit icon. For example, the pencil button. And if you edit it, again, you can edit things using a form view, for example, here. So those are 3 examples of use cases, but there are a lot more. You could use XWiki to write a CRM contact application, an HR recruitment app, some project management app for product documentation, meeting notes, blogging, calendar, etc. the sky is the limit, really. And what I would like to show you is an example. So this is a list of screenshots of what users have done with XWiki. So this is found on xwiki.org website. I just wanted to show you the variety of UIs and use cases that users have done. And this is because of this capability of the runtime development platform. So let's see how it works underneath. So a standard application that you develop normally using a traditional way, that means using Java, PHP, Node.js, etc., is that you've got libraries, so building blocks, those are the blocks on the left, and you're writing code to assemble those blocks together to do something and to generate an executable and a binary that is your runtime that you can then run and do something. And you iterate over these steps to produce your application. So this is traditional way. But with XWiki, it's a different paradigm. Is you start with a runtime. This is the XWiki that you download. And it already offers those building blocks that are stitched together to make something that works and that runs. And then what you can do is you can replace any of those blocks or add your own blocks to it so that it matches exactly the application you want to have. That means you don't start from zero. You start from having something that has authentication, that has ability to edit content, and ability to have, for example, history of the content, a defined store that can store any type of data in the database, etc. So those are the blocks. And you can remove or add blocks till you get your application that you want to have. So let's see what you can change now. What are the blocks? What are the types of blocks that you can change? So capabilities are, for example, the ability to create your own metadata inside the wiki. So let's say you want to represent a customer, for example, with a function, a name, etc. So you can create those in wiki pages. We'll see a little bit later how to do that. And then you can use them in various places in other pages. And then you've got scripting, a very strong scripting that you can use in wiki pages themselves. We support a lot of scripting languages like Velocity, Groovy, Ruby, Python, etc. And you've got access to the full API. If you remember, I was mentioning at the beginning that you had like 600 or 700 services and APIs. So those are all the APIs are accessible in scripting from your wiki pages, or actually a lot of them. I'm saying all that's not completely true, but a majority of them are accessible. You can, of course, also create Java code that access them and then makes this code available from scripts in wiki pages. I'm not going to go there, but that's also possible. And then, of course, in terms of UI, you can change completely the look and feel, change the skin, change the theme, inject any custom CSS and JavaScript in wiki pages, directly in wiki pages, which makes it extremely easy to customize the look and feel of any page or the full website completely, as you've seen in the examples just before. And we've got a concept of extension manager, so ability to load, unload extensions in your wiki. So they could be your own extensions, or they could be extensions developed by others that you can use or remove. If you start with XWiki from scratch and there are some extensions that you don't need for your project, then you can also remove them. So let's dive into the metadata, because that's very important. If you remember the homepage of XWiki that I was sharing earlier, so there are different parts. But what's important is that, so this is the UI part, but what's important is beneath the data displayed are coming from custom metadata. So typically in a wiki, the metadata you have is the title and the content. That's very typical. All wikis do that. Now XWiki go much further because it allows you to define custom metadata. Like for example, the comments here, you see it says hello OW2online 2020. That's a custom metadata. All the panels have content, and these are custom metadata. They've got titles also, by the way, but this is all custom. So let's see how it works. Let's take the example of the comment. So there is a page in the wiki called xwiki comments here, and it defines a structure of what a comment is, for example. So you see a comment as an author of type list of user, it has a date of type date, it has the comment itself of a type xtext area, etc. It can have a number for the reply, the number of the reply it corresponds to, etc. So this is the structure, definition of the structure or metadata. And then in a wiki page, any wiki page, you can actually add an instance of that structure to that page. And this is the example of the home page where I put an instance of that structure. And you see it is filled with the author being the administrator, the date is the one set here, and the comment is the one I was reading before. And then, of course, you now have metadata inside the wiki page. And then through scripting, you can access this metadata and render it the way you want. In the example here, there is some scripting that displays the comment on the screen as a section, as a part below the content on the screen. Now, you could also do it directly inside the content. You could have access to this metadata and display whatever you want in your page content. So that's very important because this is really what allows to develop those applications. Because what we don't see here is that this metadata that you create is automatically saved in the database with a normalized model of XWiki. So you don't need to take care about that. All you need to focus on is the definition of your content, of your metadata, your structure, and how to access it and what to do with it and what to display in the UI. Or what to do with it. And it doesn't have to have a display. It could do other things also, like send an email or whatever. So let's move on. I mentioned about scripting. So scripting in wiki pages, I wanted to show you what it looks like. So this is an example using a Velocity script. So Velocity is a templating language, very simple one. So this page is written in a syntax, in XWiki syntax, in markup syntax. So if we read it very quickly, what I've highlighted are the API calls. For example, here, if we follow it, it says, so it defines a variable xwql that says where all doc.content like something welcome. So that, and then it calls services.query.xwql.execute. So this is actually running a query on the whole wiki, on all the pages, and it finds all the pages that have a content having the welcome string in it. Okay. And then request, so that's asking the request if there is a confirm query string parameter that is equal to 1. Okay, so when we execute this page the first time, it doesn't have that, so it goes to the else. So it displays a bullet list of with a list of all the pages that have welcome in their content. And then it creates a link. This is the link syntax. With a label of replace welcome by bienvenue, and when you click this link, it calls the same page passing confirm equal 1 as the query string. So that means the second time this page executes, it goes to the if here inside. So it gets the xwiki.get document, it gets the document for each of the item that has welcome in their content. It modifies their content, gets the content, replace all welcome by bienvenue. So to translate it in French, and set it as the new content, and then saving the page with a message, replaced, bienvenue. And then it displays a bullet list item saying replace stuff for this page. So that's simple, but that's to show you about what it looks like. Of course, I'm showing only a few API calls here, but you've got access to thousands and tens of thousands, or actually hundreds of thousands of APIs. You've got the full power at your disposal here. Now, in terms of UI, you can also inject anything in a wiki page. You can inject any type of CSS or any type of JavaScript. You can inject that for the current page. You can inject that for all pages in the wiki or on demand, etc. So you've got a lot of options. Incidentally, if you look here, you're seeing screenshot of custom metadata. So it's the same. Injecting CSS is using a custom metadata defined as a style sheet extension page. that has the structure, and then so you just need to add this object to your page of this type, and boom, suddenly you've got the CSS injected for this page or all pages on the wiki, etc. Through the use this extension parameter below, for example, and same for the JavaScript. So this is a very nice and simple way where you can inject arbitrary CSS and JavaScript very easily in the wiki, because you just save the page and then boom, it's applied. Very easy. Last that I wanted to show you in terms of the development model was the extensions. I mentioned that 700 extensions. If you go to extensions.xwiki.org, you've got access to all of them. You see, as of today, there are 776 of them. And they can be anything. It could be a blog application, meeting manager application, forum, an LDAP authenticator, Jira macro, etc. They are really, really a lot. So those extensions are done by the community and they're accessible to you. If there is one that you need to develop your app, you can use it. But of course, you can develop your own extensions. You don't need to publish them there, but they are available to be installed directly inside your wiki through the extension manager of XWiki. So conclusion. With this ability, we can actually code a lot of different applications in XWiki. And if you look at the sum of all the applications that exist in the world, this is infinite, because every day when you come to work, you repeat things, like you want to take data from one side, combine it with some other, do something, and you keep doing this manually. But through XWiki, you've got a very easy way to automate that and create a very small application very quickly, because you've got the runtime running and you just need a few concepts to learn a few concepts, and boom, you've got an application that does things that are custom to you. And if you had to develop it with standard development process, like from Java from scratch or PHP or whatever, you would need a team of developers, and it would take quite a while to do it. And what we're saying is that with XWiki's model, the morphing application model, you can very quickly reach your goal much faster and with a lower cost. And this is actually an enabler to developing the very small application that maybe are a one-time application you need to develop and that you wouldn't develop otherwise. So this is why we call XWiki the Excel of the web, because Excel is a very versatile tool that we've all used with the macros, etc. So this is XWiki is really the Excel of the web, in the sense that with it you're able to do the same thing that Excel was doing with data, but this time with web applications. So what are the main advantages? By doing the things the way I've mentioned, with wiki pages and editing pages, you've got an iterative need-based development. That means you start from day one with having something, and iteratively you modify your wiki, you morph it to do things that you want. So it keeps working every day as you progress, and you progress along your application that you want to have. It's need-based because, of course, it's you don't need to make big plans from the beginning and wait a long time before seeing something. You can decide as you progress about what you want to have, and get the feedback of people using it, and suddenly you realize that, okay, people are using this way, so I need to do that. And then you refactor and you modify, and it works. And you've got your application that is a little bit better and different than before. Then that's why it's continuous delivery. It's version because you're based on the wiki engine, so everything you do is version. So that means we're bringing the concept of versioning content to application development. You can see the changes in the application, in the script, for example. Do a diff, see what has done, who has done what, revert, etc. You also can work collaboratively, because you can be several to edit different pages and work on the application. The developers can work on the JavaScript or the CSS, while the advanced users or developers, I don't want to say developers because you don't need to be a full-fledged developer, just advanced user is enough, can create the logic, can use the existing APIs. So it works from day one, I've mentioned that, so you got the immediate feedback. It's open source, of course, completely open source and community-based development. So I'm not going to enter here, but we've got a governance that allows equal opportunity for anyone on the xwiki.org website. So if you want to know more, just go to xwiki.org and you will find everything, including how to contact the developers and discuss with them. Thank you very much.
Our next speaker, Andrea D'Intino. In this talk, Andrea sheds some light on the concept of cryptographic data integrity and how it is implemented in OW2's project Zenroom.
Hello everyone, Andrea from Dynorg here. I'm here to tell you about Zenroom, our crypto smart contract executor for database and blockchain. So I'm gonna show you this PowerPoint, just a few slides. Then I'm gonna go through our website quickly, and later I will show you a couple of examples about how to use Zenroom once using our web-based demo website and once using Zenroom as a command line application. So, Zenroom in a nutshell. Zenroom is written in C, so NCC 99. When built, the payload is usually around 1 megabyte, and it runs in as little as 500 Ks of RAM, so it can run on very, very small systems. We have building scripts and continuous integration building for Linux, Windows, Mac, Android, and iOS on multiple platforms. So x86, x64, and ARM. Plus, we have a build for WASM that I will show you in action. We have prototype builds for embedded hardware, as well as binders for JavaScript, Java, Go, Python, Clojure, and I think that's all. Most important, Zenroom executes smart contracts in an English-like language that I will show you in a minute. One more slide. Selected features. Zenroom offers fully deterministic end-to-end encryption, where end-to-end means that you can encrypt something on an Android phone, decrypt it on iOS, and do some more operations in the browser, and do some more encryption or decryption in a server. So Zenroom runs in a fully deterministic mode, meaning that, for example, the generation of a random number, given the same random seed and the same parameters, would generate the same random number of every platform it runs on. Zenroom performs what we call traditional cryptography, so symmetric and asymmetrics, as well as zero-knowledge proof and ZK snarks, where ZK snarks is an offline version of zero-knowledge proof running in smart contract that is currently used in blockchains. In terms of curves, Zenroom can use different curves. We can do elliptic curve pairing, elliptic curve Diffie-Hellman, hashing, and signing for multiple blockchains. Currently, Zenroom supports Bitcoin and all its derivatives. We can do signature and hashing for Hyperledger Sawtooth, for Cosmos Network, and we're working on Ethereum as well. Our website, so the source code, you find it on GitHub here. We have a download page on our main website that I'm going to show you in a minute. Documentation page is dev.zenroom.org, and our web-based demo is on dev.zenroom.org/demo, which is where I'm going next. So, quickly on our website, zenroom.org. Here you can submit to our webinars. We have usually one per month. We scroll down. Here you have our source code. our documentation, and our web demo. And down here you have all our downloads. So Linux, Windows, Mac, command line, x64. We don't have a build for x86, but obviously we can do that. Windows is x86, Mac OS x86, x64. Those are builds of Zenroom as a library. So Android, ARM, ARM64 and x86, iOS, and below we have we have bindings and packages. So we have a Zenroom written in Wasm. We have an npm package for to be used in JavaScript, Python bindings, and Golang. Let's go on a little bit. Let's open the web-based demo that we also call Sandbox. So this uses Zenroom transcompiled in Wasm. So the cryptography and the smart contract execution that you see here runs in the browser. Let's start with the examples. Let's pick a very simple one, generate a key pair. So let's look at how the smart contract is written. Scenario, simple, create the key pair. Given that I'm known as, and this is my user name, let's say it's Andrea. When I create the key pair, then print all my data. I execute it pressing run, and I see the output down here. Let's try with a more complicated smart contract. Let me reload this just to be sure. Sign a message using public key encryption. This is a slightly more complicated smart contract that uses two input data to be executed, because it uses the key pair of the individual signing, and then given that I'm on Rosales and I have a key pair, when I write a string, when I create the signature, okay, this signs a message using the private key of Alice and the public key of Bob, which you can find here. We can change, the draft. This is my sign. I can change it to something else. I can write hello world. And I can run it again like the previous one. So here we'll have, this is the name of the object. This is the content, which is the encryption of this hello world. And this is the cryptographic signature that contains both the public key of Alice as well as the public key of Bob. What I'm gonna try now, I'm gonna show you how to use Zenroom as a command line application. So let's go back to our first smart contract that generates a key pair, which is this one. I'm gonna copy it, and I'm gonna go back. Well, I'm gonna not go back, to a terminal where I am using my Raspberry Pi. So here I'm using a build of Zenroom for Linux ARM. I can launch Zenroom as a common application like this. Not much is gonna happen. Now it's waiting for input. But what I'm gonna do is I'm gonna create a file and write a smart contract in it. So let's do nano contract.zen. I'm gonna paste this here. Create the key pair. Given a run as Alice, when I create the key pair, then print all the data. Yes, this should be fine. I save it, and then I run it Zenroom -z contract.zen. And here in the bottom, I have my key pair, the same way you saw it below. You saw it in the website. Next thing, I'm going to show how to save the output of the smart contract into files. So we do zen roman z contract.zen pipe t key.json. So this should redirect the output into key.json. Then I can later use somewhere else. Let me look at, yes, key.json was saved. And it should have saved only the key pair, not the usage log above. Let's look at the content now. No key.json. Here we go. Yeah, it's not formatted pretty, but I can copy it and place it in a pretty JSON. Yeah, it's the same format as the one you saw above. Okay. And obviously the key I'm using here, I could be using it in the browser as well as in a mobile application, which makes it end-to-end encryption. Okay, so that was my video. For anybody who has question, you can write me at andrea@dime.org. Thank you. Bye.
Right. So now, after this intense session, intense morning, it's time to break for lunch. We will meet in an hour for 2 sessions. One on the state of the art of open source as it is implemented. And the second one will be a roundup of European research projects that leverage open source to facilitate collaboration. See you this afternoon. The next session is about open source state of the art. It goes beyond OW2 and its code base. It shows the many faces of open source, and the next presentations are not so much about developing new technologies than about leveraging open source to implement better, more efficient and desirable solutions. Our next speaker, Jesus Escolar, Accelleris. Jesus specializes in fighting cybersecurity threats. In his talk, he intends no less than to redefine the concept of framework of cybersecurity as they are used in corporate environments.
Hello, and thank you very much for watching this recording about how to redefine corporate cybersecurity frameworks under situations like COVID-19. I'm Jesus Escolar, and I will conduct you through this little journey about the redefinition of those frameworks. So, we at Accelleris are an organization that has been active in the open source ecosystem since a long time, providing and promoting plenty of integrations and solutions. We operate in the cybersecurity and cyber intelligence across EMEA, and our goal is actually to participate, evangelizing, and promoting our knowledge across the ecosystem. So our basis is educate, help, build, and repeat again. I'm the CEO of Accelleris, and I have a large experience on the different fields related with cybersecurity and cyber intelligence. And one of the goals is that this presentation tells you about all of the frameworks that we worked during the last years, and how when this situation happened across the world, we were not ready to respond properly. And this is what we're going to see now. What are at the moment cybersecurity frameworks? Well, when you talk about security, you talk about all the different solutions that you need to put in place, and all the different elements and objects and procedures that you have to construct in order to be secure. For us, it's a process of harmonization. We have to level the same level of understanding between the different groups and business units in a company, or in an organization, in order to be able to provide a full view on the overall security. Frameworks build those best practices that the organizations use to have a vision and a strategy over the years to come, and establishing a well-known cybersecurity plans. It's guidance, it's achieving compliance, it's getting to the level where organizations want to be in terms of maturity and security. The purpose they serve is to actually integrate all the risks that are inherent in an organization, which are related to the people, the processes, and the technology used, which all combined together, they define a business. This business is at risk all the time, and the people are at risk, and the information of the company is always at risk, even the information of the consumers, or the users, or the customers. So it's very important that we have an actual element to establish a baseline across all the different security methods that we use in the different areas, to put them all together and to harmonize that. For us, this is going to be a cybersecurity framework. And it's going to be there to maintain a relationship between compliance, security incidents, and resolutions, which basically it's what we want. We want you to be compliant, to not have any security issues of any type, and when we have them, we have to be able to respond and then to resolve them and make sure that we don't have them again and again. How many cybersecurity frameworks exist? There are too many. But if we center ourselves into the most important ones, we can look, for example, at the National Institute of Standards and Technology, NIST. We can look, for example, at PCI DSS as one of the cybersecurity frameworks for card payments. We can look at the ISO models, 27001 or 002. We can look, for example, at CIS, which is mainly and broadly used across different organizations, and especially those who actually are tied a lot with, for example, cloud containers. We have plenty of open source solutions behind that help us achieve CIS compliance and make sure that we are aligned. Or, for example, we can look into the beautiful CSA, Cloud Control Matrix, CCM, which is very interesting when it comes to cloud solutions, cloud providers, to be actually compliant certified. So the goal is that we have to look into the frameworks and understand that they are actually related to a process where we see a posture, we describe who's going to be the target for that security posture that we take in, we improve the posture, we assess it, the progress, and see how good are we at deploying a framework, and then we make sure that we communicate internally against the findings and the resolutions of that particular assessment with the security posture that we wanted to apply. And then we go, as I said, we keep on looping the same process again and again and again. The problem is that those frameworks are very good when we are in an ideal world. And in an ideal world, everything happens that we wake up in the morning at 9, we go to work, everybody goes back at home at 5, like in an ideal world. But we are not in an ideal world. So we see at the moment plenty of changes in the way that the world tends to evolve, especially when it comes to technology. And then when it comes to technology means cybersecurity. How do we apply these cybersecurity elements into our organizations? And a situation like a pandemic, for example, which was totally unexpected, it was an example that we were at risk of disrupting all our activities and all our potential standardized processes with cyber attacks that we were not expecting, with changes in technologies, with accelerations in decisions. Everything came to be accelerated and forced at the moment that the pandemic exploded, and nobody was ready for that. And the worst thing about it is that when you make the wrong decisions, you actually impact cybersecurity because you're not taking in consideration what are going to be the consequences of those decisions, especially in IT. A lot of companies, we saw it in first hand, they accelerated all the processes, they took all the frameworks and they said, okay, well, these are the frameworks that we're using at the moment. And it happens that we need to put 3,000 people, for example, in remote office, giving them hardware, non-classified, non-certified, non-validated, with solutions that were not in place in the beginning, that were deployed. Usually it would take 1 or 2 years to do a proper deployment and fit into the proper cybersecurity frameworks and have everything, all the boxes ticked and having a proper audit. And a lot of companies just went crazy and they decided just to deploy everything because the business must go on. And this is something very important. If we follow the musical group Queen, they say the show must go on. And this is the first amendment that happens to be present in all the companies. You need to keep on, the business goes first. And that implies that a lot of elements, like, for example, uncontrolled devices, rogue accesses were given, a lot of uncontrolled hardware was distributed, permissions were assigned without control, and data was open to people without even classification. And all of that was totally against all of those frameworks. But nobody could do anything because we had that particular problem, how we were going to change the paradigm. Well, here we go. The way to change it is, and this is why we need to redefine in the cybersecurity frameworks for this type of situations, is that we can do it the hard way, which is ask all of these organizations to rewrite the frameworks and restructure them and actually rewrite them for all possible situations, like an exercise, which is going to be very difficult and it's going to be nearly impossible to achieve. They will have to revisit their models and actually reassess themselves and think that probably they're not doing it right, they're not doing it properly. That also means that potentially their model is not working and they have to accept it. And they will have to rebuild that model again and again for every different situation, which is a very difficult case. Rewriting or rebuilding a cybersecurity framework, it's going to be very complex when it comes from the organization who actually manages it. But So what are going to be the conclusions and takeaways that we're going to have out of the redefining the actual cybersecurity frameworks is that those models are not canon, but they are standards. So they are not actually expected to be the religion behind it. So they work when everything works. So it's not law. It's not a definition of if when we put it in place, this is the way it has to be. When everything falls into place, they actually operate properly. They are there to be challenged. We need to challenge them all the time. If we don't challenge them, there will be additional risks. Like, for example, it happened with the pandemic that we had that changed completely our way to operate our cybersecurity operations, way to use it, basically, way to implement it. When something is unexpected, we have to think again. We have to bring it back again into the table and think, okay, we have a situation that we don't know what to do with. How are we going to actually rebuild our models to fit the situation? Not the opposite. How are we going to take the situation and make it fit into our model? Every time we write something for good, it's going to be the best for all of us. So we're going to get new models. We're going to be evolving models. And we're going to have something that is built for the benefit of all of us based on these situations. And we need to create new paradigms, which means like when we have a situation like COVID, we need to think about, did somebody thought about this actual pandemic situation within their documents? And they thought, what happens when I have to open completely all the accesses to the people in the space of 24 hours, 48 hours? What are the steps to follow? None of that was considered before, and it has to be actually added by creating new ways of thinking. So how do we solve complex problems if we don't have complex solutions? And this is one of the big problematic situations that we have with the existing cybersecurity framework, is that they are very complex, and the situations that we have are also very complex. And it's very difficult to put them in place when there are situations where, as I said before, everything has to fall in place in order for everything to work properly. And in order to use properly the frameworks, we need to challenge the existing status quo. So how do we do that? Why don't we use a new paradigm? Why we don't create what we have called here a continuous cybersecurity frameworks improvement, which basically is taking the existing frameworks, putting them into place, but also challenging them to be rebuilt and make them adaptive by using serious games. And a serious game, for example, is what the Department of Homeland Security in the US does when they challenge a situation about rioting or a terrorist attack in a certain city or a pandemic situation. And for example, you can actually challenge your company with serious games, establishing what happens if tomorrow we have a massive pandemic, or we have a power outage, or we have terrorist attack, or we have a situation where the whole businesses in the whole region, even with worldwide impact, gets affected. And how can we actually, what decisions are going to be made, and what are going to be actually the impact of those business decisions into cybersecurity, have them in advance, and actually, as we say below, build a continuous learning model into your framework to actually rebuild it and rebuild it and rebuild it and adapt it to situations that you were not expecting. In order to actually have a proper cybersecurity framework, it needs to be challenged and it needs to be rebuilt. And it needs to be rebuilt based on elements that are not the existing elements that we use today, neither the metrics or the controls that we have, but new approaches and a new way of thinking. Thank you very much. I'll hope that you enjoyed the presentation, and if there are any questions, I will be very happy to take them. Thank you.
Our next speaker, Philippe Koval, Mozilla. Philippe is a software engineer who has contributed to many well-known projects such as Debian, Mozilla, and Qt. His talk is about digital twins, the ethical questions that are raised by the approach, and how to leverage open source to make it desirable through privacy by design approach.
Hi, I'm Philippe Coval and I will share some experiments about a digital twin today. So who am I? I'm a software engineer from Brittany in France, and I'm currently working as an open source contributor as a Mozilla rep on IoT projects. So I've been involved in the past in open source software for the industry, and mostly on embedded development like Tizen operating system, Yocto for automotive, and IoTVT OCF when I was at Samsung. So you can contact me at this address pearl.org/rzr, and I'm available for any cooperation or opportunities. So you can also check some previous presentation on related subject and video and social media and so on. So what are digital twin? This can be defined by this very short definition. It's a digital replica of a physical entity with a connectivity between the pair. So once one is changing, the other is updated. And at the same time, once this other one is been changing, it should reflect to reality. So we have a kind of seamless interaction between the device or its model, and we can use like a shadow object if the objects are disconnected, and we can also use this shadow object as a proxy to the actual thing to update some properties. And of course we can view this 3D object in a simulation, and you can realize this in a VR environment or augmented reality. So that's not something new because it was introduced in the year 2002, and actually a couple of years earlier I acted some kind of puppet show on the internet using sensor and VRML plugins. But today it's more easier than it used to be in the past, so I will introduce you with this concept. So I have this robot, and I can control each motors of it, and it will update the robot here. So this is a claw. I'm changing the angle of the motor for the hand, and it will open. And at the same time, the 3D model is updated at the same time. So you can create some kind of smart behavior between the device, like this using WebSync rule engine. I can update some properties of the robot. So when I'm pressing this approaching button, I can move the shoulder to 45 degrees and the arm to minus 45 and turn the light on. And at the same time I create another rule which is doing exactly the same thing but in the opposite direction. And when I press on my WebSync dashboard button, like this robot approaching button, it turns on the light as we saw, and the robot is moving in reality and in the simulation. And I have this extra sensor on the claw on my robot, and if I'm changing the color of my light from red to green and look back to the sensor, it's updated as greenish. So we have these behaviors. So I can also control from a VR environment all the dashboard using 3D element like this switch, and I can toggle it on and off just like I did before. It will update the actual robot and the 3D model, which is a simplified version. So how can digital twin can be used? So it's very wide because we have some kind of device as a service concept. So even if the device itself is not yet created, you can design it and simulate it before you have it created, and then you can deploy to an actual place, and if there is some issue you can record and play back what has been done. So that's one use case, and the other is remote controlling. That's what I've been doing just before. So this can be really helpful in a lockdown situation when you can get access to your machine, and this is useful for impact analysis and improve decision making, and it's part of the product life management. And so this can be used in many different domains from the industry So we can imagine a production chain when you have different robots working together, and if you want to see if they are getting along and they are not conflicting themselves, you can do a simulation first and try to see if something can be optimized without stopping the production. It can be also been used in city when you want to have real-time visualization about the traffic in the city or the buildings. And you can use also robotics, as I shown, and interaction with humans like robotics, and it can be used in different area. I know there is some 5G experiment using digital twins. So there is many use cases, and you can check what the W3C is trying to describing at this moment. While we're here, I want to speak about some ethical consideration, and I want to remind that in Europe, the GDPR regulation is trying to promote system to be handling privacy by design and by default. So that's an opportunity for open source software because privacy is part of our community DNA. So the challenge we have today is, can we create some digital twins with privacy in mind and to have something which is user data centric and decentralized to be more resilient? So here I'm going to introduce the web because I believe it's a platform for creating this kind of scenario. So the web has been created for interoperability in mind. It was built on open standard and free software also, and it's decentralized just like it was the internet at the beginning. And the browser itself is providing a trusted environment for isolating application. Of course, the web is programmable. You can use a REST API for interacting with web services, and if you need some real time, you can use a WebSocket technology also. And for UI and UX, we have a lot in 2D world using HTML, but also now we are targeting the 3D world using different API like WebGL to access GPU for virtual reality, and augmented reality is part of this extended reality. So I will show a couple of frameworks I've been using, and also let's mention about IoT because there is a working group at W3C which is trying to propose some standard for dealing with actual things on using the web platform. And one open source implementation is Mozilla Web Things. So it's a platform where user can control all the devices in his home, and you can control them from the web using a URI dashboard and create some kind of automation using rules. That's what I've been shown just before. And the platform itself is extensible with add-ons, so you can support new protocols or new services or use some kind of new device or radio protocol, whatever you need. There is no limit to this. And for the record, it has been inspired by the Web of Things work and simplified things description using JSON schemas. So privacy is one of the key feature of this WebThing platform because all the devices are connected together inside the user LAN. So each of them is a server connected to the gateway, which is giving access to the user. And the data stay at the edge, so there is no cloud involved because the dashboard is running on the gateway itself. And all device resource can be also shared to other applications in a safely way using JSON Web Token and REST API or WebSocket. And if you need to get access from the internet, it's also possible using a tunnel provided by PackageKite. So for the UI, we saw the 2D dashboard, which is actually SVG, and for creating 3D application, it's also possible in virtual reality or augmented reality, and now we are talking about extended reality. So that's another word for 3D rendering in a browser using different framework and handling some device sensor. So on a headset, for instance, you have some orientation sensor where you can update the view. So everything is handled by the A-frame framework I've been using, which is based on 3GS and which is based on a WebGL API, and in the end it is running on the GPU, so you have a decent performance. And the scene graph is made of different models that can be parameterized, and from the document object model you can access each element in this scene and you can, for instance, target one object and change the rotation using the 3GS object API. And you can also describe your device using a higher level API using JSON schema. So for instance, we are not talking about a rotation, but let's say we are modeling like a compass. It's just an angle which is indicating the direction of the north. So the next step now is to bind what can be measured in the real world from IoT. So we have, let's say, a compass sensor, and we can bind this to an XR environment. So I've been doing this using a web component, and while I'm here, I can show you another demonstration using Mozilla Hub. So Hubs is a social platform where you can connect together and make some chat room in a 3D environment. So it's running on a browser or mobile, and you can move in this environment just like if you were in a computer game, and all device, all clients are sharing the same environment, and they are updating at the same time. So I'm updating here my position on the phone, and it's updated in the 3D world at the same time. But it goes beyond that. So I created this 3D model in which is a replica of my this small house prototype. And when I'm moving it in the real world, it will be updated also in the 3D environment. So how does this work? So I have here a Raspberry Pi with a couple of sensors. So we have the control at on this corner of the screen when I have different sensors, like an accelerometer, a gyroscope, and a magnetic sensor. So I'm measuring here the value, the angle to the north, and if I'm moving my box, it will slowly converge to the north direction. So this is a WebSync dashboard, and I have different elements I can control from it. Like I have also other sensors on this board, like humidity, pressure, temperature, and also a joystick where you can move in different direction. It will trigger events and update this add sensor. And as you can see, there is a matrix LED where I'm indicating the north direction, but I can also control all the LED, change the colors of them. Let's move to, and also I can use this message property, and if I'm changing it, it will display hello from OW2. So I made the sensor add-on for this WebSync sensor hat for Raspberry Pi. So if you want to get started, there is a simple example which is a simulation, but it's also working on the actual device. So I'm trying to indicate the value of a sensor of a solar panel, and I'm changing the color of the solar panel on the roof of my model, and it's matching the voltage level. So that's something you can use as a simulator also. I have it running on a microcontroller on a STM32 board using IoT.js, but you can use this on a Node.js. It's quite easy to get started. So what you need to understand, so once you are including the WebSync bindings to A-frame library, then you can insert into your document a GLTF 3D model, and then you can bind one property of, so here this is the solar parts, which is part of the house model, and it's connected to the WebSync, which is at a given address. So here it's a local address, but you can use a device address or the gateway address. So this needs to be updated. So here I'm sharing also some additional resources. You can get access to the source code, and if you can give me some feedback about how can I move this project forward or try to make it bigger for any different use case, and also sponsorship is welcome. Feel free to reach me on these addresses. And if there is any issue, I really appreciate if you can report them. So thank you for everything, and now I'm open to any question. If there is any, you can also reach me online.
And our next talk is with two speakers, Vincent Flippo from Orange and Bertrand Parpoil from Auslandia. This talk is about a large-scale open-source geographical information system in production at Orange. Our speakers introduce the platform, its components, and discuss the challenges they faced with its deployment.
Hello, my name is Vincent Flippo. I'm working as a software and service architect at Orange France, and today I will tell you about our 4 years Journey project at Orange. Our goals are managing Orange network legacy data provided by Orange application, for instance Tigre, which is our reference repository containing copper telecommunication cabs supporting DSL and voice infrastructure. GeoFibre, which is our reference repository containing optical cable infrastructure. Another goal is to spread usage across Orange application. Every week we make new partnership with Orange internal application in order to provide our map or background map service with application. We have also to answer DTD-ICT, which are roadwork requests. When a company wants to proceed with a roadwork at a given place, it has to first provide a roadwork request to operators in order to avoid destructing underground cables, which cost a lot for Orange. The project team is split and half based in London, Brittany, and half based in Tunisia. It's made of several profiles like project manager, functional and software architect, expert, analyst, tester, and DevOps. We have approximately 3,500 daily users that interact with our data. As soon as Tiger and GeoFibre application will be deprecated, we expect having near 25,000 daily users. Now, our architecture. So on the top, you can see we have a business application and APIs. We have the GIS service and then data repositories. So the most important part here is GIS service. WMS is an OGC consortium standard that stands for Web Map Services. WMS API allows us to interact with rendered data from QGIS server. These data have previously been created by QGIS desktop software. WFS is an OGC consortium standard that stands for Web Feature Service. It allows us to retrieve previously geographical stored data as feature in our databases. A feature can be a fiber cable or room located in the street that hosts cables. WPS is a web processing service based on Zoo project technology that allows geographical data processing. TMS stands for Tile Map Service. It exposes the tile map background as an API for Orange internal application. And our printing service is based on Mapfish print technology in order to easily generate PDF files which are asynchronously sent by email or available for download. Now, our platform on an open source point of view. As you can see on top, on the front end, we have open layers, Angular with TypeScript, Apache Tomcat. On the API side, it's made in G2E with Apache Tomcat based on Spring Framework. The GIS service here are QGIS. QGIS server provides WMS capabilities to our APIs, GeoServer, which provide WFS capabilities to our APIs, Zoo project providing WPS, Mapfish Print3, and GeoTools, which is a geographical object library providing us the ability to parse WMS or WFS query in our Java app. Here we have PostgreSQL and PostGIS, which provides PostgreSQL extension to deal with geographical objects like shapes, coordinate, and like geoprocessing. We also have access to OpenStreetMap. And our infrastructure is based on Docker Swarm in order to deploy things easier and automatically relaunch container if one of them issues some failure. This was added since QGIS 2.14 has been migrated to QGIS 3 with a specific Linux compilation. Then we have also Ansible, which is an IT automation tool used to deploy builds on complex infrastructure, provide us an easy way to deploy our release more often. Orange open source versus editor. First, we decided to work with open source in order to have some kind of independence from editor roadmap and license model. For example, QGIS Server Dockerization was made possible because it is an open source, whereas with an editor software, it's almost impossible because of licensing issues. Also, editor protocols are sometimes not fully compliant with OGC-defined standards like WMS or WFAs. And Orange with Auslandia partnership was able then to make WMS fully compliant with OGC standard and QGIS Server. Now, let's start with the demo. This demo will take place in La Réunion, in Sainte-Marie. So, we'll start with a profile which is business manager. And this business manager has a mission, which is to bring network and communication capabilities to a new mall that will be built here in the country, as you can see with the satellite view in the country right here. So the mall will take place here. And then, okay, we'll compute the distance between the central node and this room. Okay, and the second one is the room here. Okay, so compute distance. It takes 2000 meters of fiber cable. And then we add additional cable. Okay, so we have 2008 meters. Okay, and now, okay. And we want to print stuff. So we add one map, another map here, and we will make an atlas. Okay, let's print. Okay, this is the global map. And then each selected area. Now, this is the demo ended. I will let Bertrand Parpoil speak about our partnership with Auslandia.
Hello everyone, my name is Bertrand Parpoil and I am a project manager at Auslandia, a company specialized in open source GIS architecture. As an introduction, I would like to remind that the use of web mapping, especially within large organizations such as Orange, can be complex to manage. We need to display large amounts of information without overwhelming users. This can be achieved by fine-tuning the displayed information according to zoom levels and user profiles. It is necessary to avoid too much data overlays and to limit the amount of information with specific use case definition. This management requires a strict functional administration and a good knowledge of the business. The tools must allow distinct representations of datasets according to the user's stakes. From a technical point of view, the platform must be able to deal with a huge number of objects displayed on the screen and to optimize network flows and requests filtering. Some geoprocessing are complex and must also be optimized to provide results within acceptable response time. For example, dematerialized responses to DT-DICT require intersecting the entire Orange network, and it represents hundreds of roadwork requests daily. To achieve this, we need to create databases containing more than 8 billion geographical objects. Finally, geographical data has its own specifics. Numerous formats coexist. The geographical projection's raison d'être is because the Earth is not as flat as the printed maps, despite flat Earthers. The management of these projections require expert tools usage, as well as specific skills. Misuse of projections can lead to error when computing distances or surface areas. It can also produce maps with misplaced objects. To build its network GIS platform, Orange has chosen a community-based open source strategy, which ensures that contributors are available to the entire world. This development resources pool also ensures the sustainability of the components. By relying on components supported by the Open Geospatial Consortium and the Open Source Geospatial Foundation, Orange also ensures their interoperability through the use of standardized formats and therefore guarantees the modular nature of the platform. While customizing proprietary software represents a strategical risk for the evolution of the system, using free and open source software guarantees the ability to independently develop the project's features. The availability of source code also ensures that users will be able to control the performances of the platform by checking or modifying the underlying core software. With this perspective of using free and open source software as default, Orange has decided to actively invest in open source communities. The partnership with Oslandia facilitates this involvement, allowing a close support of its internal skills, while ensuring the presence of experts likely to improve the core software. In the meantime, its internal development teams remain close to the business by developing the necessary tools for field agents. In the case of the network GIS platform, the partnership with Oslandia has resulted in several contributions that have been noticed and appreciated by the QGIS community. QGIS 3 is a new major version released at the end of 2018, and for which Orange has invested in the server part stabilization and performance improvement. We have also been able to increase the rendering capabilities useful for Orange use cases, like displaying transparent images in various contexts. For the needs of Orange's infrastructure, we built QGIS server Docker files, which are used in production, and have also been published to be used by the entire community for simplified deployments. Also, as Orange's infrastructure is based on standards like WMS or WFS, we worked on the server's compliancy with the OGC WMS specification. To do so, we created an automated test chain necessary to check compliance and regressions between versions. This compliance chain is currently deployed on the QGIS.org infrastructure and is maintained by Oslandia. The partnership has proven to be useful to exchange with the community in a simpler way. Some communities, especially QGIS, count a lot of contributors and are strongly structured. Fully understanding it completely is not simple, and acquiring this knowledge through analyzing issues and reading mailing lists is time-consuming. Then, being known by the community is also time-consuming, exchanging on mailing lists, reporting bugs, documenting features, bug fixing, or submitting new features, etc. Acknowledgement by a community as large as QGIS is an investment that is not related to an organization, but to each participating individual. Theoretically, it is not mandatory to discuss open source software modifications before the implementation, when you want to improve the product according to your own roadmap. But there are several examples of important contributions to QGIS made by companies, which have not been integrated because they had not been preceded by exchanges and validation. Having an expert company, which is already a full part of the community on your side, is a real bonus. Moreover, the knowledge of the community also allows interactions beyond a single product, for example, to go and fix bugs in the underlying libraries. This generally allows to fix several issues at the same time within different softwares. This virtuous operation leads the entire ecosystem to be more efficient and brings recognition. For all those reasons, the partnership has proven its usefulness for Orange and for the QGIS community. In concrete terms, such a partnership requires a high level of responsiveness and flexibility on both sides. This is made possible by the use of an adapted platform, in our case GitLab, with a ticket-based functioning in order to speed up exchanges and to keep trace of them. The prepaid time credit means we have a great transparency with regards to the charges necessary and actually consumed. We use daily agile methods. The prepaid time credit also eliminates the validation steps required to sign codes for each intervention in order to save time while limiting paperwork. Thank you, everyone.
The next talk is by Pascal Seignier and Silvio Di Mulete, both from Orange. This talk describes a full-stack open-source application that manages capacity planning for the Orange network infrastructure. It tells us about the challenges of deploying it throughout a complex organization such as Orange France.
Hello everyone, my name is Pascal Seignier. I am Solutions Manager in Paris on delivery and capacity monitoring tools with 20 years of experience in Orange Group in project management, such as end-to-end monitoring with robots and probes. I am accompanied by Silvio Di Mulete from Bucharest, Romania, where he works as a technical project manager at Orange Services. He has more than 15 years of experience with open source software with a focus on system administration, databases, and software development. Today, we would like to share with you our experience on the use of open source products for the capacity measurement of our network infrastructures. It's an opportunity for me to send a warm greeting to Mayan Boulakou, who accompanied us until very recently in this adventure. It is indeed around the Cacti product that our team was formed in 2013. You should know that before that, there was a heterogeneous use of this open source product, which allows the collection of metrics on network equipment to monitor its performance and capacity. Everyone installed and used it for their own needs without being possible to gather all this data. We were asked to be able to offer a package dedicated to the internal use of Orange based on a unique technical architecture, a standardization of the metrics collected, and an interfacing with other tools of our ecosystem. This is how Silvio and his colleagues set up a skill center around Cacti to offer each year new ways of industrializing this simple tool to allow better use of our thousands of equipment. This consisted of multiple adjustments such as customizing HMIs to integrate with Orange uses, successive Cacti command bundle packages using the Apache, PHP, MySQL versions recommended in the group, an automated installation with operating documentation, and support in the migration to these new versions. We also had to bring new features, validation and standardization of the metrics collected on each equipment model, automatic addition of new network equipment in production from an orchestrator based on the asset management repository, and adding alarms according to thresholds. The team also focused on evaluating other open source capability tools for collecting, such as graphite. Despite everything, we have come up against the limits of the Cacti project in our objective of being able to continue to capitalize on its simplicity and therefore its richness. With more than 50 independent instances, we had no global view of the metrics collected. This prevented us from being able to correlate information and be more reactive in running tasks. It was therefore necessary to set up a platform to be able to explore all data, if possible, while preserving the maximum of history. This platform allows us to centralize interfaces with our software partners for easier use. Finally, to be able to benefit from capacity forecasts and automatic alarming, it was necessary to be able to connect this platform to Orange Big Data. To better understand the work that has been done since 2013 around Cacti and Big Data, I hand over to Silvio, who will tell you about the approach that the team has followed.
Hello, I'm Silvio and I'm going to start out with Cacti. Cacti is an open source web-based network monitoring software designed as a front-end application for the open source tool RRD tool. Cacti allows a user to poll services at predetermined intervals and graph the resulting data. It is generally used to graph time series data of metrics such as CPU load, network bandwidth utilization, memory, and others. A common usage is to monitor network traffic by polling a network interface through the use of the Simple Network Management Protocol, SNMP. Some information about SNMP for those who haven't worked with it. It's an internet standard protocol for collecting and organizing information about managed devices. It's usually found in networking hardware like routers, switches, modems, as well as servers, workstations, and others. In our case, Cacti connects to an SNMP-enabled device and queries for an object ID. The device then answers with the corresponding value for that object ID, and the value is stored in Cacti and later used to create graphs. Cacti can be extended to monitor any source via different scripts. The Cacti open source project started in 2001, nearly 20 years ago, and we can say it matured very well over the years, with new features being added constantly. In Orange, in order to make sure that the deployment of Cacti is easy and uniform, we've created an installer package because the internal network area doesn't have an internet connection. The installer package had to be a comprehensive collection of software which made sure that once deployed, the admin had all the tools he could possibly require to run and debug Cacti, as well as to integrate it with other Orange platforms. We started by adding Cacti alongside Spine, Spine being a very fast polar written in C, and continuing with the latest packages of Nginx, PHP, MariaDB, RRDTool, PHPMyAdmin, NetSNMP. We've also added all the Cacti plugins available in their latest working version. Concerning Cacti templates, we have created our own based on a uniform logic. The type of equipment, maker and version, characteristic. Is it standard or specific use? Of course, in order to provide a complete Cacti experience, we offer the Cacti admin the possibility of importing and using community templates as well. We also add CLI tools for the admin to debug or develop new functionalities based on his or her needs. Here we have some monitoring tools like HTOP, Glances, MyTop, which is a monitoring tool for MariaDB, networking tools like TCP, dump, SOCAT, and other CLI tools to meet every need and taste. Not wanting to start an editor war-like situation, we included in the package all the requested software by the admins, even if it serves the same function. After the deployment of a Cacti VM in Orange, Cacti using Spine is tasked with collecting data from different data center network devices. Some need to be collected each minute, others each 5 minutes. It depends on the device and the admin. Considering that the data center can be a pretty big place, other platforms are available, and when adding a new device to production, it can be a chore to start declaring it in every platform. In order to make things more integrated and automated, we've added several PHP APIs to integrate Cacti with the other platforms available in the data center. That being said, if a network device is added in one platform, Cacti will be notified and will add the device automatically to its list and will graph the device's interfaces based on the rules that the Cacti admin establishes. Trying to make an efficient use out of the resources made available for Cacti, we customize each instance for its specific requirement depending on the foreseen usage. We achieve the efficiency by doing two things. We scale up by allocating more resources to a specific instance of Cacti, or we scale out when the situation demands it. This is not a perfect solution because it introduces some limitations. For instance, each Cacti collects a specific domain and there is no end-to-end view because some Cacti nodes can be isolated network-wise. Moving along to the big data part of our presentation, when we first approach this subject, we must consider the needs of such a platform and make some clarifications and classifications. Why make the classification? The use case will influence the infrastructure and tools that you will have to use. For Orange needs, we've identified two use cases. Real-time or near real-time, which consists of problem detection and issue notification, and adaptive context, which help reduce expenses. The other use case is non-real-time, which consists of behavior analysis to help predict problems and limitations. Keep in mind, we're talking about the behavior of the network, not about the behavior of people. When we have established what type of need we have, we can move to identifying the tools required. When we started classifying the open source tools available for building a big data platform, we were amazed by the sheer diversity and range. Mostly the tools we used were from the Apache Software Foundation, even if they were grouped together by Hortonworks, which is now part of Cloudera. Taking a look at the plethora of tools available for big data, one must consider using only the bare minimum because the overabundance of tools can be difficult to manage, as well as raising the total cost of ownership. Creating the proof of concept, we've tested several software solutions in order to identify what is the most appropriate for our use case. We've looked at the ELK stack, Elasticsearch, Logstash, Kibana, but we found a limitation in capacity as Elasticsearch is efficient only up to 32 gigabits of RAM and 300 gigabits of data per node. Talking about storage of data, we've also tested CrateDB, InfluxDB, Prometheus, Graphite, OpenTCDB, MongoDB, and others, which are not mentioned in the slide due to the lack of space. The point I'm trying to make is that extracting data from Cacti, which had a structured database, MariaDB in our case, we saw that going in the NoSQL direction posed more problems than it solved, so we decided to go once more with MariaDB, thinking we could upgrade it once their column store solution became more stable. At the time of the proof of concept, column store had just appeared with version 1, and it seemed a little bit like a work in progress, not really a finished product. As everything must have a name, we named our platform PDG. We started by adding a REST API to each Cacti server, which would have the role of extracting data from the internal Cacti flow and make it available for transport. Once this was in place, we needed to set on an ATL, extract, transform, load. We chose to deploy Apache NiFi and Zookeeper for the use of Apache Ambari. The NiFi cluster calls to all the Cacti VMs at the same time and extracts the time series data each 1 or 5 minutes, depending on how each Cacti is configured to collect its own data. The metadata, complementary information like equipment, name, device, capability, and others as such, are extracted once per day during low usage intervals, aka off business hours. After configuring NiFi to extract data from the Cacti VMs, we had to send the same data in two directions, real-time processing and non-real-time processing. For the non-real-time use case, we had no real issues as it wasn't a time-critical process. All we had to do is send the data from one NiFi cluster to another. The real challenge came when we had to store the data for the near real-time usage. Storing all that data is easily doable in a MariaDB database, but extracting and processing the data at the same time as the insertion proved to be a challenge, considering we only had one available server. In order to make that feasible, we had to partition the biggest table by week, the biggest table being the one that contains all the time series data points, which right now consists about 13 billion metrics. By doing so, we managed to reduce the total execution time of a query from 120 seconds to 1 or 2 seconds. Of course, it involved some query optimizing, especially the join order of the tables. The MariaDB partitioning script would also have to take care of deleting all partitions once the new ones were created. And thankfully, the alter table drop partition query is a fast one, considering each partition has roughly 100 gigabits. As an example of our PDG platform capability, using Grafana, we created a graph comparison between two network ports from two different equipments. Data which was collected by two different Cactis from two different network regions. This sort of usage is employed in order to have an end-to-end view of a network flow, overcoming limitations such as geographical location, network virtualization, access and domain restrictions. Another example, also using Grafana, is the computation of CPU average usage from a day ago with specific time intervals such as business hours and non-business hours. We can also establish a trend by comparing with the values computed a week before during the same time period. In conclusion, we would like to leave you with some questions. Does anyone feel like they could use this? Is some part of our presentation of interest to you? We love to be able to share our code and expertise, even if it's highly customized to the Orange's needs and environment. Maybe we can make it a little bit more abstract in order to be easily deployable in other environments. Just let us know. That's all from us. Thank you for your attention. Goodbye.
Our next speaker is Jenma Erledan from Atos. Jenma is an open source evangelist at Atos, involved with Nextcloud and Framasoft. His talk is about Nextcloud and the Frama Cloud project based on Nextcloud and the types of services that Atos delivers on the solution.
So, let's talk about Nextcloud, the open source collaborative cloud platform. Who I am? I'm Genma, I'm a French blogger, I'm a member of Framasoft, I'm a free software user since year 2003, I'm a Nextcloud user, and the co-founder of the Nextcloud Friends community. My job? I actually work for Atos as an open source evangelist. So, Nextcloud. Maybe you've heard about OwnCloud. The original OwnCloud developer, Frank Karliczek, forked OwnCloud and created Nextcloud in year 2006. Differences to OwnCloud. While Nextcloud was originally a fork of the OwnCloud project, there are now many differences. While OwnCloud offers an open source community edition, they also offer a proprietary enterprise edition with additional features and support subscription. Nextcloud instead use the same public code base for both free and paid users. Nextcloud popularity also appears to have overtaken that of OwnCloud. A simple definition of Nextcloud can be a suite of client-server software for creating and using file hosting services. Nextcloud is free and open source, which means that everyone is allowed to install and operate it on their own private server devices. Nextcloud has several advantages, including a modern web interfaces, an easy-to-use mobile application, a large community of developers who enrich the core of Nextcloud, and the ecosystem of applications around Nextcloud. Nextcloud architecture. The Nextcloud server is written in the PHP and JavaScript scripting languages. For remote access, it employs SabreDAV and open source WebDAV server. Nextcloud is designed to work with several database management systems, including SQLite, MariaDB, MySQL, Oracle Database, and PostgreSQL. Nextcloud Store. Since the software is modular, it can be extended with plugins to implement extra functionality. Developers can offer their extension to other users for installation via a manufacturer-operated platform. This platform communicates with the Nextcloud instances via an open protocol. The app stores contain over 200 extensions. With the help of this extension, many functionalities can be added. Nextcloud Store can be seen as a whole bunch of other applications to complement and enrich Nextcloud with thematic packages. Nextcloud clients. In order for desktop machines to synchronize files with their Nextcloud server, desktop clients are available for PCs running Windows, Mac OS X, or Linux. Mobile clients exist for iOS and Android devices. Files and other data, such as calendars, contacts, or bookmarks, can also be accessed, managed, and uploaded using a web browser without any additional software. Any updates to the file systems are pushed to all computers and mobile devices connected to a user account. Nextcloud Hub. Nextcloud Hub is the first completely integrated on-premises content collaboration platform on the market, ready for a new generation of users who expect seamless online collaboration capabilities out of the box. Nextcloud File, enterprise file sync and share. Nextcloud Files offer an on-premise universal file access and sync platform with powerful collaboration capabilities on desktop, mobile, and web interfaces. Nextcloud Talk, calls, chat, and web meetings. Nextcloud Talk delivers on-premise private audio-video conferencing and text chat through browser and mobile interfaces with integrated screen sharing and SIP integration. Nextcloud GroupWare, calendar, contacts, and email. Nextcloud GroupWare integrates calendar, contacts, email, and other productivity features to help teams get their work done faster, easier, on your terms. Powerful search. Nextcloud includes a powerful full-text search engine capable of using Elasticsearch as backend. Its flexible plugin-based interface enables search capabilities beyond files and accommodate other backend solutions like Apache Solr. Nextcloud Online Office Editor. Two online Office suites from the browser that will allow you to edit the documents that are physically stored in the Nextcloud file space. First one is OnlyOffice. OnlyOffice integration in Nextcloud empowers your users to collaborate on Office documents with team members in real time. Compatibility with Microsoft Office formats means perfect document every time. OnlyOffice has the following features: Spreadsheets editor, organize and manage your data online in XLS, ODS, and CVS files with over 400 formulas and create colorful visualization. Presentation builder, express ideas in beautiful presentation store in PPTX on ODP or export to PDF full of charts, shapes, and images. Document writer, open, edit, and collaborate on Word, ODT, PDF, or HTML documents in real time with powerful formatting and layout capabilities. Full support for Microsoft format Office like DocX and PPTX is provided, as well as import and export of the open document format. Some screenshots: Spreadsheet editor, presentation builder, document writer. Collabora. Collabora is the overshoot. Collabora is a company that offers level 3 support for LibreOffice. It's one of the main contributors to LibreOffice. Collabora Online is a version of LibreOffice Online which has a long-term support, LTS, validated and signed security updates, and a service level agreement support. Collabora features are the following. You can create new documents based on LibreOffice Writer, Calc, Impress. You can do simultaneous and collaborative edition of the same document, track changes and version. Supported formats are the same than LibreOffice, open document format, or XML format. Some screenshots: Collabora Writer, Collabora Calc, Collabora Impress. Collabora versus OnlyOffice. Collabora is a visual representation of a server-hosted editor sent to your browser. The whole process runs on the server and is instantly shown within Collabora interfaces. OnlyOffice. In OnlyOffice, there are resources of a client that is rely on. The editor indeed works right in your browser and constantly exchanges its data with the server. Let's talk about security in Nextcloud. Compliant by design. Nextcloud products are designed with compliance in mind, providing extensive data policy enforcement, encryption, user management, and auditing capabilities. It's GDPR compliant. You have auditing capabilities and file access control. Protected sharing. For Nextcloud customers, securely exchanging data is the key. Nextcloud offers industry standard protection mechanism and adds innovative and unique capabilities like video verification. Secure share link. Nextcloud features industry-leading protection for file shares. Share password, expiration date, access rights, read-write sharing, hide download, secure view, hide file listing, file drop, file access control, video verification. Administrator can set defaults or enforce all these options. Security of data. You have a functionality of remote wipe. Remote wipe will work on systems not under management of the company. You can wipe the document from their devices when the collaboration has ended. Remote wipe can be used on a per-device basis by users on a per-user basis by the administrator. ransomware protection. Nextcloud offering automated one-click ransomware recovery tools. Conclusion. Why Nextcloud? Because of control. Protect, control, and monitor data and communication across your company. Guarantee compliance with business and legal requirements. Keep your data on server you own at all times. Nothing leaks, not even metadata. Because of productivity. Enable productivity across any platform, whether it's in the office or on the road, to share, collaborate, and communicate across organizational boundaries. Nextcloud provides transparent access to data on any storage. Because of community, enjoy constant improvement for a thriving and transparent, entirely open source community development model, free of lock-ins or paywalls. Enjoy the benefits of enterprise support when you need it. Go on nextcloud.com, try it, use it, adopt it. With Nextcloud, regain control. Nextcloud is a self-hosted productivity platform that keeps you in control.
Okay, now we're taking a 15-minute break. Of course, the chat channels remain open. The next session is about collaborative research and development. This session is about research and technology innovation in software engineering as it is enabled by open source. The presentations in this session propose an update on selected projects that are funded by the European Commission. And our next speaker is Vincent Lecartier from the Free Software Foundation. In this talk, Vincent discusses challenges in the research and development of artificial intelligence, how they slow down its progress and adoption, and how open source solutions can help address them.
Hello, my name is Vincent Lecartier. I'm a PhD student at the Lyon University Hospital. My thesis is about artificial intelligence and healthcare, and I'm also a Free Software Foundation Europe volunteer. Today I'd like to talk about the upcoming challenges in artificial intelligence research and development, including fairness, parameters reuse, and model training. So for the first part of my talk about fairness, I'd like to introduce some vocabulary. The true positives and true negatives are where the predictions were correct, meaning that you predicted true and the observed value was true, or you predicted false and the observed value was false. False positive and false negatives are where when the predictions were incorrect, so you predicted false and the observed value was true, or the other way around. To explain the concept of fairness in algorithms, I'd like to give you a few examples. The COMPASS recidivism scoring algorithm tells if criminals are going to recidivate their crime or not in some United States courts. The problem with this algorithm is that it had different performance depending on the skin color. The algorithm often mistakenly predicted a high risk of recidivism for black people and a low risk for white people. You can see this in the false positive rate and the false negative rate. The false positive rate were almost 50% for black people, and the false negative rate was almost 50% for white people. Another example, this time in healthcare. So this is a graph summarizing the result of an algorithm predicting the risk score for patients. So the x-axis tells the risk score predicted by the algorithm, and the y-axis predicts the number of conditions of the patients. As you can see, black people had to be sicker to have the same predicted risk score as white people. So this algorithm was giving different results according to the skin color, which is unfair, obviously. So an algorithm can be unfair because it can be there can be bias in the input data itself, or it can be trained with the wrong evaluation metric, or the algorithm can be trained with the right evaluation metric, but it forgets about everything else. So it optimizes for this metric, but not for fairness, for example. Or you can have a bad prediction model that introduce unfairness. Here I'd like to introduce you to a fair loss function. A loss function is used during the training of an algorithm to tell how accurate it is, that is, how well it is performing. So according to this metric, you adjust the parameter of the model to improve its accuracy. To create a loss function that is fair, I add to this regular loss value. So this value comes from a function. This function tells if a result is fair or not from the predictions of the algorithm. So what you do is you sum the result of this function for all possible value of a protected attribute. The protected attribute is something sensitive, like the gender, the religion, the skin color, and so on. So you sum up the result of this function for all possible values of a protected attribute, you divide by the minimum, and you try to minimize this value as well as the loss, meaning that you both optimize for the accuracy of the model and for its fairness at the same time. The second part of my talk is about parameters reuse. So what are parameters? Parameters in the context of deep learning is small numbers that are added or multiplied together, and they are organized into layers and they lead to a prediction. In real-world examples, there are millions or billions of those parameters. Reusing parameters means reusing some layers from already trained model as part of your model training, meaning that when you train your model to give accurate predictions, you reuse parameters from already successful and already trained model. So I'll give you some time to read this comic. So training a model can be really time consuming. It can take hours or days to train a large model. By reusing some already trained model and some parameters, you avoid doing some computation, which saves you a lot of time. Reusing parameters also saves a lot of energy. This table summarizes a study about the energy impact of natural language processing models. The results are in kilowatt per hour multiplied by the PUE, which is the impact, the energy impact of the data center itself, like things like cooling the machines and so on. And the results are also in carbon dioxide. And you can see that training those models takes a lot of energy. So by don't having to train them yourself and by reusing already trained model in natural language processing, you avoid a lot of energy cost. Parameters reuse is also good for knowledge sharing. By sharing models, layers, and parameters with each other, we can leverage knowledge from multiple models as part of one model. So we share the knowledge accumulated by different models as part of a bigger one to achieve maybe greater goals. So what is needed is to make it easy to reuse parameters of models. We want to have some licensing and some platforms where we can easily share the different models so that everyone can reuse them. And also, we need to find ways to reuse parameters in more domains of AI. Some part of artificial intelligence currently don't make it easy to reuse models' parameters. For example, there is no way currently in reinforcement learning to reuse some already trained model as part of other models. The third part of my talk is about model training optimization. So model training optimization means optimizing the way the model is going to be trained. This is done by a process called hyperparameters tuning. So what is hyperparameters tuning? To explain this, I'm going to make an analogy with cake baking. So when you bake a cake, you have control over several parameters. You can control the temperature of the oven, the baking time, and the cooling time of the cake. And modifying those parameters impact the taste and thus the quality of the cake. So this is the same with models. You have a bunch of parameters, and adjusting these parameters controlled the accuracy, that is how well the model is going to perform with several parameters. So for example, here I have 3 different parameters. Kernel takes 3 possible values, C takes 10 possible values, and gamma takes 10 possible values. So now if you want to try all combination of those parameters to find the best ones, you have 300 candidates to try. That is 300 models to train. And if you want to use tenfold cross-validation, you have 3,000 models to train to find the best combination of the hyperparameters. So this is really time-consuming and expensive. But there are several solutions. You can use something called early stopping. So if I go back to the example of the cake, if the cake is already burned, you know that there is no point in trying to increase the temperature further. You know that increasing the temperature will lead to a more burned cake, so it's pointless. So this is the same with models. You know that if the accuracy is not great, trying to increase the value of a parameter is not going to help. So you can stop and don't try to increase further this parameter. You can also try to converge towards the best solution, that is, converge towards the best combination of hyperparameters. What you do is you monitor the accuracy of the model over several tries, that is, over several candidates, and you try to find the most promising combination of hyperparameters, and you derive new candidates based on the most promising result so far. So it converges towards the best solution. What you can do also is to make the model training faster. So maybe you don't need all your data or all your the complexity of your training loop to adjust hyperparameters. So maybe you can reduce the number of epochs required to train the model, or you can maybe reduce the size of the dataset used to train the model in the context of hyperparameters tuning. That will make the model training faster, and therefore you can try more candidates, more combination of hyperparameters. So thank you for listening, and please ask any questions you may have.
And our next speakers are Geir Orn and Marta Rosinska from the Oslo University. In this presentation, Geir and Marta describe the Morphemic project approach to the implementation of multi-cloud native strategies from the cloud deployment and design stages down to execution.
So, welcome to this presentation on autonomous multi-cloud serverless deployment and optimization management by the Melodic platform, which is an open source middleware that allows you to deploy your application multi-cloud. And this is done by Marta and myself. So the idea behind Melodic is that we have the need to deploy an application in a multi-cloud setting and often also cross-cloud, so that we are using many clouds at the same time, including, for instance, a private cloud and a public cloud from a public cloud provider. Now, this application is then monitored during runtime, and if it needs to be changed and the configuration and the resources offered to the application needs to be changed, then Melodic will automatically reconfigure the application. And the good thing about Melodic is that it supports cross-cloud. So as I said, many cloud providers at the same time for the application. And it is fully open source based on open source frameworks. So why did we start the Melodic project and develop this platform? Well, the first is that there is a problem using multiple cloud providers, and it is an even larger problem using multiple cloud providers at the same time. So we wanted to have one single interface to all these cloud providers. We also wanted to have a unified way to deploy different application components, such as virtual machines, containers, and serverless functions, and all of this respecting the data constraints and the data that the application is operating upon. And the last part is especially important, for instance, now in Europe, where you have GDPR controlling where you can store and operate on data. We also wanted to have autonomic deployment because changes might be needed to the resources of your application at times when you are not available and where you would like your application to stay responsive to the application users, even if there is no person that is able to deploy the application on your behalf 24/7. So that means we need to have some kind of an automatic optimization of the cloud resources that are used by your application. So Melodic is able to scale out the resources when needed and scale in again when it's no longer needed. So what are the key features of Melodic? Well, as I said, it's autonomic deployment, and that is the sort of the key thing here, that Melodic takes care of your application. It acts on your behalf for the application. And it does so in order to maximize the utility of the application seen from your point as the application owner. So it's based on the application characteristics and the measurement of the real application, and then it tries to reconfigure to the best possible way. It supports big data frameworks like Hadoop and Spark, and it does so in respect of the data constraints that you have. So if data cannot be moved, or if data has to be on a local server, then Melodic will deploy the computational components to where the data is and not the other way around. And finally, it is also secure, so it supports a single secure authentication of the application user and ensures that only these authorized users can deploy your application to the cloud. And it's built to be enterprise ready. By that we mean it should be highly available, and Melodic itself is scalable so that you can ask it to deploy complicated applications or simple applications.
Camel is cloud application modeling and execution language, and it is used to model an application. It is a domain-specific and cloud provider-agnostic language based on Eclipse modeling framework and similar to Tosca. It covers all aspects of application modeling. It's possible to model in Camel the application components, connections between them, security aspects. It supports various types of application components, script-based, Spark components, Docker containers, and serverless components. It allows also for complex infrastructure requirements modeling, and what is probably the most important and unique, it allows for modeling of user preferences, utility function, and constraints. It makes the optimization process in Melodic possible. What is more, it supports models at runtime modeling. It is used to express the application state during the runtime. In other words, it supports the description of application state before it starts to be deployed, during optimization, and when the application is running. Camel is built from modules. It currently contains many modules, and it will have more because they are work in progress on extensions. What is important to notice is the fact that these modules can be reused in more than one Camel application model. For example, in the Melodic, we have some predefined metric models that are reused in many application models. How does the Melodic work? Firstly, user needs to create a Camel model for his application and set up initial parameters for the application. After that, Melodic starts the work. It downloads the offers from all cloud providers that user has access. It calculates the best cloud environment for application and deploys it automatically. The reasoning part is done by solving a constraint optimization problem, maximizing the utility function automatically generated from the Camel model. To solve the constraint problems, Melodic uses various solvers, among others, a stochastic learning automata solver based on reinforcement learning and Monte Carlo tree search solver. Currently, Melodic supports deployment on big cloud providers like AWS, GCP, or Azure, and also OpenStack. When the application is ready and working, Melodic starts collecting defined by the user metrics about currently running configuration. If the better solution appears or actual solution becomes unacceptable because one of the constraints, the reconfiguration is triggered. Melodic continues basic looking for better solution for deployment and makes the reconfiguration if newly found solution is significantly better than the current one. It means that it can move application components to another cloud provider, to another virtual machine, add more instances, or whatever Melodic establishes the best deployment. Therefore, during the application execution, Melodic manages to always have the most optimal environment.
So what is the best deployment when it comes to Melodic? Well, what we do is we are first going to collect metrics of the running application, which means that these metric values are representing the current configuration of the application and the current context. So how many users the application has, for instance, can be one of these metric values. Or the time it takes to produce a result can be another metric value. And this provides for a very flexible way to calculate the utility for this particular context. So for this particular number of users, for instance, what will then be the best utility for you as the owner of the application? This means that the focus will be on the business value rather than on the technicalities of collecting the metric values and making the right decision for this particular context. And of course, in all optimization, there might be trade-offs between cost performance and this kind of availability issues, whatever you represent in the utility. And Melodic aims to do that automatically for you. So if you have formulated a good utility balancing these different concerns, then Melodic will make sure that this is the best possible deployment based on your utility. So let's look at an example. For instance, say that you have an image recognition application where the actual image recognizer function or classifier is a function that you deploy to a serverless platform. So the first Melodic will do in this case is to deploy the actual recognizer function, which is the classifier, and then once up running, it will start processing images coming in and produce classified images as output. And this is a function which will be automatically scaled by the platform if the load becomes more than what can be handled consequently by the classifier function. Now, if you have an image which is not recognized, then you will need a retraining of the classifier. So in this case, you will deploy, for instance, a big data framework like Spark, and you will give Spark one worker to work on retraining the classifier. Then you will, of course, estimate the time it takes for processing some data sets, and you will see if this will allow you to timely train the classifier for your application needs. If this is not the case, well, then you will give more workers to the Spark training, and these workers will then automatically be taken into consideration by Spark, and the estimated time should go down. Once you are happy with the estimated time, then you can simply wait for the new classifier and eventually deploy this classifier as needed. So this means that the right-hand side here is the autonomic retraining and configuration, the application management done by the Melodic platform on your behalf. And it makes sure that it's all deployed when needed and all undeployed when no longer needed.
The workflow with Melodic is very simple. You as a user need to model your application in Camel, deploy the Melodic platform. Then you just need to submit your Camel model to your Melodic instance, push the big green button to start the deployment of the application, and observe. Thanks to Melodic UI, you will be able to see the reasoning process of Melodic, but you are not expected to do anything more. You can connect, relax, and enjoy your application working. It is very important to mention that Melodic is enterprise ready and it is used by some companies. You also can download and try Melodic, and we encourage you to do that. Melodic itself is released under MPL 2.0 license. Currently, the third release of Melodic is ready. The project is being further developed and it is hosted on OW2 repository. We also encourage for your contribution to the project.
So thank you for your attention, and we hope that you will now try out Melodic, download it, and if you have any problems or questions, please feel free to contact us. We are here to help you. So thank you.
Thank you.
Our next speaker is Huy Song from Sintef. Huy is a researcher at Sintef, Norway. In this presentation, he would like to share his journey with the Enact research project towards enabling DevOps in IoT and how open source makes the journey feasible and fun.
My name is Huy Song. I'm a researcher with Sintef Norway. Together with my colleague Nicola, I would like to first thank OW2 for offering us this opportunity to share with you what we are doing in a project called Enact. Enact is a research project funded by the European Commission under the 2020 program. The project is about how to support DevOps as a new way for software development for Internet of Things. We found this problem, and we have some good ideas that we believe that will improve the way people develop IoT software. We did some experiment, prototyping, tool development, and we're now in the phase of trying to use them in the real cases from some use cases. So this is a typical research process. If you switch DevOps to some other topics, for example, COVID-19, then the process is almost the same, from problem to research to innovation or manufacturing. But what makes this problem a little bit special, which also makes us wanted to share it in this conference, is that there is actually a hidden loop. The whole process is strongly supported or powered by open source. We elaborate that in the following slides. So come back to the problem again. Software development for Internet of Things. When we think about software development, most of us will have the image somehow like the one shown on the left, of a smart guy or girl sitting in front of a clean desk with just the monitors, keyboard, and mouse. And you do some change to your code. When you're satisfied, you click some button, and then you can go out to grab some coffee, have some chat with a colleague, and when you're back, everything is online. You start to see the monitoring result on how the system is actually running in the cloud. Easy and clean. But when you think about IoT software development, I think many of us will still have the image somehow like the one on the right. You have a desk which is filled with some prototype devices that weld together in a strange way, old-fashioned monitor, just to make sure you can get some output from some old devices. You still do the change on your code, but after that you need to build it and somehow transfer the code into some, in a special way, into some devices. And after that you monitor how it works in an old way, and if it's something wrong, it's not so easy to figure out what is happening. But does it have to be this way? No, I think as IoT developers, we also like DevOps. We also wanted to be able to focus on the frequent and small changes, small improvements to our system. And we want to enjoy automation. We also like to see the feedback from not only the devices on the desk, but also the ones from our real customers. But it's not so easy, since IoT is anyway special. It's different from development for cloud software. So first thing, that it is distributed and is diverse. You have hundreds of thousands of IoT devices deployed far away from each other, and they are somehow different. Even if within the same application you may purchase those devices from different manufacturers, or from the same one, but they are produced maybe 3 months apart, and then they're different. The devices have different way for you to deploy software. Some of them are good enough to support Docker containers, but some others even don't have operating system. Other devices are having different context, capabilities, and user preferences, and you have to handle scalability really seriously. And to make it worse, the smart IoT systems also have actuators, which can impact the physical world. Then you can imagine what would happen if the different actuators want to work on the physical world in different ways. So all these lead to challenges that are not handled by the current tools that are provided for cloud-based software development. That was the question or the research problem: how to support the continuous development and operation of trustworthy smart IoT systems. We try to solve this problem by coming up with a set of software development tools which can be used to automate different phases of the DevOps loop. I'd like to go quickly through all these tools by a complete pipeline. So in the middle is the tool Genesis, which is our solution for the infrastructure as code for IoT, which solve the challenge about different devices having different ways to deploy code. So you provide an abstract deployment model together with the code that you compiled it for the different hardware architectures, and then we deploy them into the devices automatically using our engines that are specially developed for different types of devices. The same tools is also used for different phases, like we can give it for the risk management. We use it to support the coding. We use it to support coding, and then we use the same model to analyze what are the potential conflicts between actuators, and use this for and provide the automatic actuation conflict manager. And after everything is ready, we give it to the test and the simulation environment. That is what we provide for the devs phase. And for ops, the same model is first used to a tool called DevInAct, which distributes the parallel active deployment plans into a large number of devices according to their different contexts. And after that, for each device, we use the Genesis engine to actually deploy the code into these devices. After the code is running in the system, we use the same model as the central artifact to coordinate all the feedbacks we get from the system through different tools like the access control, the automatic adaptation based on online learning, and root cause analysis for the behavior problems. So all these come back to the same model and pushed back to the dev phase using the same deployment model. That are all the tools. And you can see that all the research is around how to come up with the best software development tools that fit the different phases of IoT development. We don't want to reinvent the wheels. So the best way, we believe, is to improve, adapt, and customize the existing tools so that those tools that people are familiar with and they like working together with, and then we adapt them to be able to use in the best way for the IoT development. So now comes the question of where we can find all these tools. And I think the answer is very clear now, that nowhere than open source community that we can find the best software development tools. So those are just some examples of the open source tools that we use to develop as a basis to develop our tool. For some of the tools, we really go into the source code, make some hacking changes within it. For some of them, we mainly use them as a service. We call the APIs and get the information from them and adapt it in our way, so that to make the support for the IoT development. So just take one example. So one of the tools is called DaVinAct. Yeah, we reused our project name. So the tool is about how to distribute some potential or alternative deployment plans into a large number of devices, depending on their context. So analyzed the problem, I figured out that the first thing we need is to know what are the devices and what are the context of each of them. This is what we call the fleet monitoring. After that, we assign the deployment plans to all of them based on the context, and then the mapping will be used as input for the infrastructure as code solutions to actually install the software modules into the devices. By dividing the system into these three components, we found that for fleet monitoring, we have good open source frameworks, and one of them is the Azure IoT Hub, which has both online service and also an open source code base. I think 10 years ago, when you come into an open source community and shout out the word Microsoft, you probably get a lot of angry starings, but I think that's changed. So Microsoft is actually contributing to open source. And as for the device deployment, some of the new infrastructure as code solutions like Ansible, and also our own solution, Genesis, can also work here. So the problem then is more on the fleet assignment, and we can focus on this as our research effort, and we come up with a solution, model-based solution. So we abstract the information into a standard model and use the theory prover to solve this problem in a mathematical way. Pilot use cases. We also want our tools to benefit people outside of the project. So one of the efforts is that some people from the project has decided to start up their own company in January 2019. The company is about providing the software as a service solution for continuous risk management, providing to the DevOps teams. The company started to have some real users from the health and construction domain. But that's one of the 10 tools. What about the others? As a project funded by public money, we really want that all people can benefit from the tools and can even join us to maintain these tools and improve them even after the project is over. So you can probably already guess what I want to say in the next slide. Yes, we have our framework open sourced from the very beginning on GitLab, and we have submitted our application to OW2. So this is our story about a research project powered by open source. Thank you very much.
Our next speakers are Alexandra Bagnato from SoftTeam and Maxime Compastier from ActiveEon. Alexandra and Maxime explain how the Melodic platform supports advanced optimization concepts for distributed computing applications.
Hello, good afternoon. We are here today to present to you the Morphemic project, Advanced Proactive and Polymorphic Cloud Application Adaptation. The presentation will be done by myself, Alessandra Bagnato from SoftTeam, and by Maxime Compastier from ActiveEon. The vision of our project is to simplify cloud application modeling and to continuously optimize and morph the deployment model to take advantage of all the beneficial cloud capabilities. To do that, we are building up on two OW2 technologies as core building blocks. One of them is Melodic. Melodic is one Horizon 2020 project. Is a research project that started in 2017 and ended in 2019 and is already hosted as OW2 project, and you can find it at HTTPS Melodic Cloud. It is provider of cloud deployment monitoring and context adaptation capability. The second OW2 technology that is our building block is Proactive.
Proactive is a project that has integrated the OW2 community since its early beginning. It is a project that has been carried by Enria Sofia Antipoulis in the Oasis team, and that has been commercialized as part of a spin-off program by ActiveEon. It is actually a distributed scheduler that enable the user to specify their workload as workflow and to put them into execution into distributed environment. In the context of Morphemic, it will provide the runtime scheduling for multi-cloud and edge environment. And you can check further information from our website. Morphemic is built around two core concepts. The first one is a polymorph architecture, whose objective is to maximize the utility of an application by adapting the technical form of its component. And meaning by technical forms, we are considering virtual component as a virtual machine, are encapsulated as container, as serverless components such as function as a service function, and as jobs of big data frameworks. The more tricky notion here is the application utility. This is a notion developed inside Morphemic project to evaluate the usability of an application given a specific technical context. We determine this function based on the requirements that are expressed in the specification in the camel model, and this user utility is continuously evaluated as an operation matrix based on technical form properties all along the application execution. The second core concept is the proactive adaptation. The goal here is to forecast execution context to anticipate the requirement in development. To this end, we predict the execution context based on the prediction of resource needs, so that we can identify which deployment configuration should be put in use. Therefore, we can anticipate the deployment by conducting an effective adaptation of the application to provide a seamless experience to the end user. We want to implement those two core concepts inside the Morphemic deployment platform by providing a complete cross-cloud edge-ready deployment platform with advanced features such as utility-based function, multi-layer, and runtime monitoring feature. To this end, we wanted to exploit the CAML modeling language, CAML, which stands for Cloud Application Modeling and Execution Language, and which has already been used and industrialized inside the Melodic project. The preliminary architecture of this project is organized as an extension of the Melodic architecture. But we extend this by based on the two core concepts. The proactive adaptation is sustained by the work package 2 by having a continuous monitoring on the construction of an utility prediction that by the content of the work package 2 components, and that are later consolidated inside a predicted model used inside work package 3 component. The work package 3 is responsible for the polymorphic planning adaptation and will provide the adaptation based on this predict model on the code archetype on the polymorphic model that are later used later used as optimized model and put into execution to Melodic platform. The requirement of the specification is constrained by a modeling that is handled inside the work package 1 work that is in charge of extending the CAML model to reach this objective. To provide a seamless user experience, the work package 5 is responsible in providing a user interface that will manage the deployment of application, the enactment on the data placement, and the management of hardware accelerator. The architecture and the integration are part of the work package 4 task.
Now we are going to see some more detail on the unified user interface. So for Morphemic, we aim to have a unified user interface for application modeling, management, monitoring, and operation. We want to provide a uniform user interface access for Morphemic tools and components. To do that, we start from the design phase with Softeam camel modeling, and we start modeling it in the OML modeling tool Modelio. Modelio is an open source modeling tool that is developed within Softeam and is part of the project within the Work Package 5 user interface feature. Softeam aims to build the cloud application modeling and execution language, CAML 3.0, that will be the outcome of the project, and we give a visual design tool based on this open source tool Modelio. Right now we have been starting working on the CAML 2.0 version that was developed in Melodic, and we will go on with this specification, including all the needed change that will be included in CAML 3.0. In this slide, you can see a simple example of how complicated and big is the CAML world. In this, we can see the slide on the deployment diagram. You can see how the application components are modeled, and one-to-one to this is the XMI that is associated with this model. In this second slide, you can see an example always taken from CAML model of the metric model. So the metric model, you can have in here the measurable attribute utility or the measurable attribute price.
The second building block that will be used for the work package 5 is active and proactive that will be used as a runtime for distributed environment. More specifically, our objective is to conduct the orchestration for Morphemic platform and its application based on this technology. The key challenge to reach this objective is to apply the workflow paradigm that is run by the proactive scheduler to the needs of application orchestration. The second challenge is to identify and to comply with the constraint of heterogeneous deployment by being able to cope with cloud resource, edge resource, hardware accelerator, and big data jobs. To reach and to address those challenges, we have set up a strategy based on two technical approaches. First, the extension of the proactive resource manager so that to be able to cope with the variability of the infrastructure resource required by Morphemic. The second is preparation in on-the-fly fashion of management workflow to enact the deployment and the management of Morphemic application that will be later put into execution by submission to the proactive scheduler. Therefore, Activion leads the operation environment work package and more specifically the runtime scheduling task. We are glad to be part of OW2 as we consider this community as a strategic enabler for the Morphemic project. First, we have seen that OW2 is an environment for fostering innovation, provided the technical assistance and the tooling and support we have gained from this community for project operation. We are also very thankful for the guidance for research project industrialization and the expertise the community has gained. Last but not least, we would like to thank the community for their support in this approach. We are also happy to have some key members of the consortium that come with key know-how from the OW2 community, such as 7 persons that come as the integration leader of the project, Activion, that is the technology provider to provide the runtime for multi-cloud and edge environment, engineering as a technology provider for application profiling, and the University of Oslo that will contribute as a scientific member on the proactive polymorphic adaptation feature.
We continue with the final slides, and we invite you to join us in the open source community of Morphemic. You can already join us to extend this Morphemic platform, the most advanced multi-cloud proactive project. Of course, we said Morphemic is based on Melodic, which is accepted as OW2 project. You can already have source code and repository of Melodic hosted on OW2, and you can also already check the source code and repository for Morphemic on GitLab OW2. So please don't hesitate to contact us and to follow us. You can see in this slide our website, all the social network where we are present, and we invite you to follow us. So we are in Facebook, LinkedIn, and Twitter. And of course, if you want to ask any question of the two presenters that you had today here, Maxime and me, you can reach us, contact us on email, Twitter, that you can see in this slide. So thank you so much to the audience and to OW2 to have given us this opportunity to present this wonderful project. And hopefully we will see you next year in the same OW2 to present you the progress that we did. Thank you very much.
Our next speaker is Alexandre Lefebvre from UShareSoft. Alex is head of the professional services at UShareSoft. In this talk, he introduces ReachOut, the beta testing campaign platform for research projects, and he gives us a demonstration.
Hello. This presentation will explain what ReachOut is all about. Then we will take a tour of the ReachOut Beta Center. So what is ReachOut? It's a support action funded by the European Commission. Fraunhofer Focus coordinates the project, and the other two partners are OW2 and UShareSoft. And by the way, I'm Alex from UShareSoft and very happy to be presenting ReachOut in OW2online 20. So our goal at ReachOut is to help European research projects in the area of software engineering develop market value and reach out to their end users by developing their own beta testing campaigns. Also, you can note that ReachOut is also open to all European SMEs and open source projects. So creating value for research projects means more than simply producing project deliverables. This is what we call the delivery challenge. So there's many more project attributes, which are listed on these slides, which create value for the project results. As we will see, beta testing helps developing those product attributes, and thus it increases the market value of the project. Beta testing is a key phase in a software development cycle. After the initial alpha version, which is internal to the project, and before the product is ready, the beta version is to be tested by external end users over a short period of time. This is what beta testing campaign is all about. So beta testing has a number of benefits. It provides a focus point that helps align the efforts and the expectations of the project partners. Beta testing also provides feedback, which can be used to increase the quality of the product. Beta testing helps enforcing those other necessary product attributes, such as documentation and packaging, and thus it increases the project value. And finally, the feedback provided by external beta testers is very useful to help identify future exploitation of the project results. So for a project, being able to develop and implement its own beta testing campaign is an important milestone. It proves that the project has what it takes to engage with external actors, users, partners, to bring value to the market and to start developing its own ecosystem. So at ReachOut, we have developed a whole 5-stage methodology to help you implement your own beta testing campaign. That means deciding the objectives of the campaign and the role of the partner, so basically the strategy of the campaign. It also means preparing the software for beta testing, the testing scenario, and the questionnaire. It also means writing documentation and communication material, and then engaging with beta testers and managing them. And finally, analyzing the results and sharing them. So the whole methodology is available in detail on the ReachOut website. So ReachOut provides you with tools and templates for each of those building blocks. So this is the role of the Beta Center, and we'll take you through those tools in the Beta Center tour shortly. First, campaign managers can register on the Beta Center. They are given their own campaign manager page from which they access the resources that ReachOut provides them with. In particular, using the form we provide, a campaign page can be automatically generated together with the associated questionnaire for beta testers. We also provide campaign managers with a monitoring dashboard. So these are 24 checkpoints about the management, about the preparation, and about the execution of the campaign. This dashboard can be used to monitor the progress of the campaign together with the ReachOut project team. It can be used to communicate with the partners and also communicate with the reviewers. Typically, a beta testing campaign would take 3 to 5 months, with the first phase of preparation of 1 to 2 months, then 1 to 2 months of execution, that is engaging with the beta testers themselves, and finally 1 month for analyzing the results. So how do you get started? Well, the first step is to go to the Reach Out website and to register your project. Then we will set up a call with you to go through the Reach Out methodology in details, go through your timeline, and help you implement your beta testing campaign. One important point, all of this is free. So let's now have a look at the Reach Out Beta Center. So this is the Reach Out Beta Center, and it offers two types of experience. First, for the campaign manager himself, so the project leader, you can register as the campaign manager. So it's a self-service registration. So it's all self-service. You just provide your details, and then you have access to an account, which will allow you to register your campaign. We'll see that in a minute. The second type of experience is that of the beta tester. So the beta tester can check out a number of campaigns that are available. So here we've got some. So you've got the current campaigns, and below you've got the past campaigns here on the platform. So let's now look at the material which we have developed and which is present on the Beta Center. So in the Beta Center methodology page, you can find a superset of the slides which I'm presenting now. So that's a superset of the slide which includes more details about the different elements of the methodology. There's also the methodology as a document, which you can download and read in detail. So the table of contents shows you the different steps that we cover in the methodology. So also you can find in the Beta Center the tools and templates that we've put together for you. So this contains explanation about the monitoring dashboard. We'll show you that one in an example in a few minutes. It contains a section about software packaging. So software packaging is an important aspect of setting up together a beta testing campaign. So from past experience, especially in the past project that we were involved with, which was called AppHub, we had to assemble together virtual machines for various software and software projects. And often it's happened to us that we did find some instructions which sent us to a GitHub repository where there was a README file where the compilation instructions were incomplete or were not working anymore, and so on and so forth. So it's very important if you have if you have a project to be tested, and if you want beta testers to be able to provide you with some feedback, that they're able to install your software. So this is an important point here. And Reach Out also provides you with another tool called the Reach Out Factory, which allows you to assemble your project if you haven't assembled your software yet, in a way that beta testers will be able to use. So if we go back to the tools and templates, we also provide you with a beta documentation checklist. So this checklist takes you through the necessary documents and documentation that you should provide. We also have a page about the beta tester incentives. So this is a question that we often have, is how do you reward beta testers? So we've done some research on this, and in fact, beta testing needs to be acknowledged rather than rewarded. So rewarding is good if you can. So if you have a free T-shirt, but saying thank you and recognizing them is good. So at Reach Out, we're organizing a Hall of Fame for the beta testers, and we will put them together forward on the platform. There's also more reading material that you can find about ideas for rewarding your beta testers. Then, of course, we have worked on a beta testing agreement, so it's very important when you gather feedback from people that you respect the legislation. So there's a beta testing agreement that we have here, which also contains informed consent and of course the data protection page, which you can reuse. So the campaign page we will see in a few minutes, and the questionnaires as well. And the communication package, which we've put together for you, contains a number of communication material to be able to communicate about your campaign, recruit beta testers. So a few words on recruiting beta testers. That's a question that we often have, is how do you recruit them? Does ReachOut recruit them for us, a project, or does the project do it? So it's a bit of a mix, actually. So of course, through ReachOut, we have registered a number of projects. We are in contact with quite a few projects who've already done a campaign. So they become a source of beta testers themselves. The first source of beta testers, of course, is your project partners. So that includes, for example, if you have academic partners, all the students that would work for the academic partners and the researchers. So there's a mix of beta testers that you will have access to through ReachOut and beta testers that you have through your current project. So let's have a quick look at the beta center now. I will log in as one of the users. So let's log in here as ReachOut, which has a campaign about ReachOut. So if I now go to my homepage, I can see that I have a project called ReachOut with which you can click here. So in this project, I have one campaign called Testing the ReachOut Platform. So I can see the details here, which is organized in section. I can create a new campaign if you want to, because of course one project may have several campaigns for testing different software components. And I can take a look at the project dashboard. So the project dashboard, as we said earlier, has 3 sections for the management, preparation, and execution. And if I edit the dashboard, for each of the checkpoints, I have here a tooltip which tells me what I should be looking at in terms of actions to take, so that I can self-assess myself. So now, if I go back to my campaign, I can take a look at the survey itself. So if I go to Lime Survey, which is the tool here, I can take a look at the survey. The survey has a structure with a number of questions. Each of those are customizable. The wording of it, the structure of it, you can add and delete questions if you want to. There's no problem. And also, I can look at the results. So if I want to look at the responses, I can take a look at the statistics, for example, here. And I can view the statistics in the simple mode. That will show me the different answers that I've received so far for my campaign. So, so you can of course export those questions in a spreadsheet type mode if you want to. So if we go back to the presentation now, note again that although ReachOut has been funded by the European Commission for its 2020 projects, it's also open to all European SMEs and open source projects, thus, of course, OW2 project. So thank you for watching this presentation, and we hope to see you soon on ReachOut. Don't hesitate to contact us if you need any help. Thank you very much.
Our next speaker is Virgil Prevosto from CEA. Virgil is a researcher at the Software Safety and Security Lab in the CEA. His talk introduces the Decoder project. This project aims at helping developers get an understanding of a given piece of software on which they need to work.
Hello, and thanks for attending this presentation at OW2online. My name is Virgil Prevosto. I'm a researcher at CList in Saclay, near Paris, and I'm acting as the technical leader of the H2020 Decoder project that I will talk about. Decoder stands for Developer Companion for Documented and Annotated Code Reference, and you can of course find more information on its website. It started at the beginning of 2019 for a duration of 3 years, meaning that we are currently in the middle of the project. The main aim of the project consists in providing a unified platform which will let users manage all kinds of information on a software project, including, of course, the source code itself, inline comments, documentations, models, test scenarios and results, formal specifications, and/or static analysis results. Decoder has identified 3 main roles for its intended users, namely developers, reviewers, and maintainers, but the platform has the ambition to be useful for any stakeholder during the whole life cycle of a software project, from design to deployment to maintenance and upgrade. Decoder is coordinated by Technikon in Austria, with support from CList for technical leadership. Very roughly speaking, it will mix software modeling and analysis tools, notably from CList and UPV, the University of Valencia in Spain, with natural language processing tools, again from CList and Tree Technology, again in Spain. Making the best use of the platform will of course require defining some methodology, a collective effort led by UPV, while Capgemini in Spain provides its expertise in UX design to develop a user interface for the platform. Finally, the whole product will be assessed against various use cases in C, C++, and Java, provided by Capgemini, Tree Technology, Cisco in Germany, and OW2 in France, with also coordinating the communication efforts of Decoder and hosting us today. At the core of the project lies the elaboration of the Persistent Knowledge Monitor, or PKM, a database meant to host all the relevant documents for a given software project, as mentioned before, during the whole life cycle of said project. The PKM itself will of course come with tools for feeding the database and retrieving information from it. Within the project, this will notably be the case for natural language processing tools able to extract information from existing documentation or from the code itself, and to provide valuable insight on what the code is supposed to do, including potentially in the form of formal specifications. Similarly, static and dynamic analysis tools such as Pharmacy, OpenGML, or Tester should be able to take into account those additional sources of information in order to refine their analysis and to give back the results to the PKM. Finally, all such information should also be made directly available to end users through their favorite ID or a dedicated interface developed within the project, or through the generation of new documents, PDF or Word or other formats, UML models, or other kind of documents. Of course, in order to make all these tools communicate smoothly with the PKM, some common schemas have to be designed. In fact, since the PKM is such a central piece of the project, its design and the development of its first prototype was one of the major objectives of the first half of Decoder. For that, we gathered requirements from all partners in order to ensure that the database would cover as much as possible the needs of all its intended users. As we needed it to store very heterogeneous documents, document-oriented, NoSQL database was an obvious choice, and we finally settled on MongoDB, or at least its latest 8GPL version, 3.4, for the time being. JSON will be the primary format for extended documents with the PKM, and first schema has been proposed, with which we will try to adhere to existing standard proposals in the areas where they exist, such as for static analysis results, Sarif, for storing compilation information, JCDB from CMake, or for interactions with the IDE, the Language Server Protocol, LSP. At the lowest level, interactions with the PKM are conducted through MongoDB's own JavaScript driver, on top of which we have designed a lower level API, which is currently ready, to let the tools involved in the project feed the PKM with their own data, and to make basic queries to the PKM. Currently under design, there is an higher level API which is more suitable for end users' interactions. And again under design, we find a web-based interface to manage the PKM. Another very important aspect of the project is the usage of natural language processing techniques to automatically identify correspondences between the documentation and the corresponding source code. Knowledge extractions could be done in both directions, either to derive more formal requirements from an English, French, Spanish, German document, or to help writing the documentation by extracting directly some part of it from the code. In this area, the first part of the project has been dedicated to gather datasets in order to train the models and to the training itself. For that, existing datasets external to the project have been identified and used, as well as the use cases of the projects, notably the ones in Java and C++. Initial experiments are encouraging. In the direction from code to natural language, focus was made on grouping tokens according to their lexical values, with a first application towards detecting potential misuse of identifiers. For instance, if a developer used an X where it would have been more natural to find a Y, either in the code or in a comment near the code. In the reverse direction, from natural language to code, the idea is to use neural machine translation techniques, in which the code will simply be seen as another foreign language. Models are currently trying to compute a similarity level between the source and the corresponding informal description of what the code is supposed to do, again with interesting results. Last but not least, some work has been dedicated to define the so-called abstract semi-formal models, or ASFM for short, where the idea is to provide a kind of graphical language which would allow describing the effects of a function on the data structures involved. For instance, when we have lists or trees or graphs. Such format could act as an intermediary between the source code and formal specifications on the one hand, and natural language descriptions on the other hand, hence its name of semi-formal. It would also thus constitute a convenient target for natural language processing tools as an intermediary towards generating formal specifications, which might be difficult to attain directly. Furthermore, it is also planned to add a graphical debugger that would let users play with SFM objects in order to better understand the behavior of the underlying program and the data structures that are supported by ASFM. Currently, a first version is available with a common core which is understood by each tools in the platform, and in some places some tool-specific extensions. All in all, ASFM provides some kind of an abstraction layer on top of the PKM's lower level representations of the code in particular, and to some extent can be seen as a part of the higher level API. In addition, prototypes for creating ASFM models from the code are currently available. To summarize the work done so far, we are approaching the point where the PKM server will be available for extensive beta testing. First, internally, notably to refine the functionalities that are offered both by the low-level API and the A-level API, which is currently under design, and to complete the bindings with the client under development. Similarly, we also have to finalize the integration of the NLP tools within the PKM. After that, it will be time to open up beta testing to external, possibly some kind of adventurous users, including interfacing with other tools, or simply let users play with the graphical interface available. For that, it might be interesting to use the reach out platform that has just been presented, but currently this is still under discussion within Decoder. And this concludes what I wanted to tell you about Decoder, so thank you for listening, and feel free, of course, to contact us if you want more information.
Our next speaker, Amir Mir. Amir is a PhD student in software engineering at the Delft University of Technology. In his presentation, he introduces the FASTN technology of fine-grained package and dependency management and how it applies to Rust and Java software ecosystems.
Hi everyone, my name is Emir. I'm a PhD candidate at Delft University of Technology. It's my pleasure to present the FASTN project for OW2online conference. In this talk, first I talk about open source software, package management, and package dependency networks, in short PDNs, the current issues with PDNs, existing solutions, and the root cause of the issues. And I will present the FASTN project, its solution, the FASTN architecture, the current state of the project, and finally I will talk about some examples of the FASTN workflow. Nowadays, software developers reuse code to reduce development costs, and open source software and libraries are hosted on centralized repositories such as Maven and PyPy. Thanks to the open source software, the dream of collaborative development is now possible. Open source libraries and software are considered as a building block for creating new software. However, when there are hundreds of thousands of software packages out there, the package management becomes an important issue. And basically, there are some package managers out there to help developers resolve dependencies and download required libraries for their own software. For example, we have an example here. SLF4J is a Java package, and basically it's a POM file here. As we can see, there are dependencies for SLF4J. For example, log4j is a dependency for SLF4J package. And the important part is that the log4j is also a Java package, but it has its own dependencies as listed on the right side. When there are hundreds of thousands of packages out there, basically it creates a huge and complex networks. And basically each package has its own versions, which makes things more complicated. Because of the complexity of the PDNs, recently we saw some big failures. For example, LeftPad project in 2016. Which made a large number of websites back then unavailable and down. Another important failure was the Equifax in 2017, which affected around 147 million of people in America, and their credit card information was revealed. Basically, the recent failures that I mentioned happened because of the issues with the PDNs. From a developer's perspective, there are basically 4 problems. Observability, which means how can I know a package is outdated, or the update problem, how can I check that an update doesn't break my current software. And the trust problem, which means that how can I trust code on the internet when I have important data on my own laptop or PC? And from a maintenance perspective, again, we have the update problem. How can I know that if I update the dependency of my package, it doesn't break the clients and the user who use my own library? And the deprecation problem, for example, if a developer removes a feature from a library, it may break the client's problem, the client side, the client's program. And for example, the lack of incentive, which means that the developers spend their own free time, but they expect some kind of income or money while working on the open source software. There are some existing solutions out there for solving the issues of PDNs. For example, we have some services like GitHub and Dependabot. But usually these solutions have their own problems. For example, they do not support for assessing updates For example, if I update a dependency for my own package, basically they don't tell you whether it's safe to update or not. Another issue is no help with impact assessment. For example, if I change a function in my library, how many clients will be affected after that? And they may produce some false positives. Basically, they recommend you to do something that basically you should not do. The root cause of the issues that I discussed with PDNs comes from the fact that the current approaches, they examine the problem at the package level. For example, here we have app version 1, which depends on library 1 version 3.2. But this approach only looks at the problem at the package level. However, there are another solution which is called dependency networks, CDNs. This approach is more precise because we examine the function calls in the packages, which basically gives us more insight and information to solve the issues with the PDNs. Inspired by the issues of the PDNs, the FASTEN project launched in January 2019. It stands for Fine-Grained Analysis of Software Ecosystems as Network. And the main goal of the project basically is to solve the issues of PDNs by making package management more robust and intelligent. And basically we create a centralized service to host the graphs and serve the analysis. And the consortium that we have right now consists of several universities and several companies in industry. Basically, our solution provide more precise license compliance. For example, we help developers to know whether they violate copyrights or not, and we provide more precise risk profiling. For example, we help developers to know whether a security vulnerability affects their packages or not. And we provide a more precise change impact analysis. For example, how many packages will be affected if I change a method in my own library. And the ultimate goal of the FASTEN project is to integrate the solution with the current package managers that are out there right now, for example, PyPy and Maven. And this is our ultimate goal. This is the overview of the FASTEN architecture. On the left side, we have data streams that consist of package repositories from PyPy, Maven, and Debian, and Rust Cargo, and we have vulnerability information from CVE and NVD. On the middle, we have the FASTEN server, which consists of call graph generators. Because again, the FASTEN solution is based on the CDNs. We examine the issues of the PDNs at the function level rather than at the package level. We have an analysis layer which has several components such as security, compliance, quality and risk, and change impact. As I mentioned in the previous slide, the FASTEN solution provide more precise impact analysis and license compliance and security and quality assessment. And we have a storage layer which consists of two databases, one for storing graphs and another one for storing metadata of call graphs. And on the right side, we provide basically a web UI and REST API to help developers use our own toolset and solutions that we provide. And basically, the continuous integration servers can also benefit from the REST API that we provide. As I mentioned in the previous slide, the metadata database is an important part in the architecture. It basically stores the metadata of the call graphs that we generate for packages. For example, we have a table packages which stores information about the package, and we have another table for package versions, each version of basically a package. And we have a modules table. For example, in the case of Java, a module corresponds to a class. And to store the call graphs, we also have callables tables which represent the nodes in the call graph, and we have edges table for storing the edges of a call graph. And on the right side, as shown, we have files table for storing files of source code files. Since the project started, a year and a half is past. At the moment, we have alpha version of the project. One of our main achievements was to generate 1.2 million Java call graphs. To the best of our knowledge, this is the first time that in the software engineering community, basically more than 1 million call graph is generated. And we also generated 80,000 Rust call graphs. And we also generated call graphs for Debian packages. We deployed the Fastest server on Kubernetes clusters for scalability, which helped us to generate more than 1 million call graphs. And we made the initial implementation of a storage layer available. We have basically the storage layer, as I mentioned before, it consists of the metadata database, and it has a graph database for faster access. Now we have provided some examples of the FastSum workflow. For example, here we have an example for PyPy, which has a tool named Pipe to update the packages and to install packages. For example, after the fast integration with the PyPy, basically a developer can update the dependencies of his or her package with confidence without worrying about the breaking his own package. Another example is to decide whether to use a library or not for a software package. Again, after the fast integration, basically the developer can see the security vulnerabilities of a package and basically whether it's safe to update, whether it's safe to use a library or not. And thank you all for listening to this talk and your attention. If you have any questions, please check out our website for more information, and we made our tool set open source and available on our GitHub organization.
So this concludes the first day of our virtual conference. I hope you enjoyed it. It didn't go too bad, did it? It's been a long day. I'm not going to keep you long, so just have a couple of announcements. Tomorrow, Thursday, we resume the conference at 9:20 sharp, 9:20 CEST or Continental European Summertime. Our virtual doors open at 9, so please come early and hang out on the Say Hello channel, see who's there. Tomorrow, our conference turns its attention to open source governance. It's a very important topic these days, and it's only half a day, but we have 10 high-level presentations, so don't miss out. And for those who don't join us tomorrow, remember the OW2 Community Day, so it's on November 3rd. Save the date. We will circulate more information later. So with that, enjoy the rest of the day, and I hope to see you all tomorrow on the OW2 Online channel.